we are going to discuss another important property, which is time scaling property. So what's the meaning of time scaling property? Means either you can elongate the signal or either you can compress the signal. So for f of t, the Fourier transform is f of omega. Then f of at as a Fourier transform 1 by mod a into f of omega by a. A can be the positive, A can be negative. F of t by m is 3 plus a by 1 by a in the above formula. Then we are going to get here mod a into f of a omega. We are going to get. So I request you to remember only this formula. If you know this one, we can get the value of this one also. Here also it's same thing. Here also a can be either positive or a can be negative. A can be positive, A can be negative. Suppose what I will do for this equation, I'll multiply by 1 by mod a on the both sides. Then I'm going to get 1 by mod a into f of t by a is nothing but which has the Fourier transform f of a omega. So if you remember this only one formula, it is addition. You need to remember, because if you in the case of a, if we replace 1 by a, we are going to get the remaining things. So always remember here f of t has the Fourier transform f of omega, then f of at has the Fourier transform 1 by mod a into f of omega by a. For a can be the positive, A can be negative. Suppose if a is greater than 1 means it is compressing the signal. If a is less than 1 means it is elongating the signal. So this one I have already told you. So time scaling property. So f of t has the Fourier transform f of omega, then f of at has the Fourier transform 1 by mod a into f of omega by a. Here a can be the positive or a can be the negative. So as I have already told you, if a is greater than 1 means it is basically compressing the signal. If a is less than 1 means it is basically elongating the signal. So this point always you have to keep in your mind. So now the next property, which is a frequency shifting. Frequency shifting means you are shifting the signal in the frequency domain. So then what is going to happen in the time domain that we need to figure out. So for f of t, the Fourier transform is f of omega. Then f of omega minus omega naught, the inverse Fourier transform is f of t into e to the power of j omega naught t. And for f of t into e to the power of minus j omega naught t, the Fourier transform is f of omega plus omega naught. So let me derive this one so that you can easily able to understand. See, let me derive this part so that you can easily able to understand. Sometimes you don't have to remember the formula, but if you know the concept, you can get it. So this is very simple, right? So I'll derive this one. So f of t has the Fourier transform. What is the Fourier transform? F of omega is equal to integration of t is equal to minus infinity to plus infinity. F of t into e to the power of minus j omega t dt. Suppose what I will do, I will do basically now I will take a new signal f of t, which is nothing but f of t into e to the power of j omega naught t. Then what will happen? Let us see. In place of f of t, I need to substitute these things. So t is equal to minus infinity plus infinity. In place of f of t, I need to write f of t into e to the power of plus j omega naught t into e to the power of minus j omega t into dt. So from this, what I will do, I will take minus infinity plus infinity here f of t. So now what I will do, e to the power of minus j, I will take common. Then what I am going to get here, omega minus omega naught into t. dt you are going to get. So if you take minus j common, you are going to get omega minus omega naught into t. So what is, this is basically in the format of this one, right? Here omega, here omega. Here omega minus omega naught means here it should be f of omega minus omega naught. So this will be now f of omega minus omega naught. So this is what we can see clearly. So this part you have to grab here. So this part let me grab. So this part let me grab here. So this is what that we are going to get. So this point you have to keep in your mind. So therefore we can say this is the correct solution of this question. So therefore you have to remember this type of concepts you have to keep in your mind. So therefore we can say that. So what I can say now finally. So for f of t into the power of j omega naught t as a Fourier transform f of omega minus omega. Here omega means here also omega. Here omega minus omega means here also omega minus omega. Then what will happen for the reverse fashion? Reverse fashion means f of t into e to the power of minus j omega naught t as the Fourier transform. It is f of omega plus omega naught. So these are very important things. So these things always you have to keep in your mind. So therefore we can say f of t into e to the power of j omega naught t as a Fourier transform f of omega minus omega naught. F of t into e to the power of minus j omega naught t as a Fourier transform f of omega plus omega naught. Here plus means here minus means here plus. So this one I already have told you, but now also I derived this one also you have to keep in your mind. Then what is the modulation theorem? Modulation theorem is very simple. F of t into cos omega naught t, what will be the Fourier transform? So cos omega naught t, you know what is cos omega naught t? Cos omega naught t, just now we have discussed, right? What is cos omega naught t? Just now we have discussed. So cos omega naught t, I already told you. So how you can write cos omega naught t? I already told you. So cos omega naught t, how you can write? Cos omega naught t is nothing but, just now we have discussed, e to the power of j omega naught t plus e to the power of minus j omega naught t by 2, right? So now multiply the signal f of t. So if you multiply the signal, then you are going to get in this fashion, right? So this one plus this one by 2. So if you simplify, we are going to get this one plus this one by 2. So if you simplify, this one plus this one by 2, you have to do. That's it. This one plus this one divided by 2. Same thing we have got. Now, f of t into sin omega naught t. What is sin omega naught t? Sin omega naught t, you know. Sin omega naught t is nothing but e to the power of j omega naught t minus e to the power of minus j omega naught t by 2j. By 2j. So same thing here also. So if you multiply f of t, we are going to get this one minus this one by 2j. So this one minus this one by 2j. Same thing, right? So this one minus this one by 2j. So if you know this formula, then getting this is a very piece of cake. So modulation means simply we can say multiplying the signal f of t by cos omega naught t or sin omega naught t. That is called as the modulation theorem. So what is the meaning of modulation theorem? Modulation means you are multiplying the signal f of t either by cos omega naught t or sin omega naught t. That is called as a modulation. So f of t into cos omega naught t has a Fourier transform 1 by 2 into f of omega minus omega naught plus f of omega plus omega naught. And f of t into sin omega naught t has a Fourier transform 1 by 2j into f of omega minus omega naught minus f of omega plus omega naught. So this concept, based on this concept, we have solved this one. Now time differentiation. Another concept is time differentiation. So for f of t, if the Fourier transform is f of omega, then d by dt of f of t as a Fourier transform f of omega into j omega, or you can say j omega into f of omega. Then kth derivative of f of t has a Fourier transform j omega over the power of k into f of omega. So this is a very basic concept, right? So as I've already told you, an important point. There is a point I've already told you. Suppose for f of t, if the Laplace transform is f of s, then d by then the kth derivative of f of t as a Laplace transform as the power of k into f of s. So based on this formula, just replace s by j omega. That's it. So then what we are going to get? So we are going to get like this. So what is the thing we are going to get? Then d by dt of f of t means k is equal to 1. So and s is equal to j omega. So therefore we are going to get like this. Suppose second derivative. So second derivative of f of t means j omega whole square. So j omega whole square into f of omega. So if you know the Laplace transform formula, it is a very piece of cake. In case of this, substitute j omega. That's it. So for f of t, the Laplace transform is f of s, and kth derivative of f of t is the Laplace transform is the power of k to f of s. In place of s, substitute j omega. That's it. So d by dt of f of t means k is equal to 1. So j omega into f of omega. D square by dt square f of t means it has a Fourier transform j omega whole square into f of omega. Same thing, right? If suppose k means j omega over the power of k into f of omega. Suppose k the derivative. So d by k the derivative. So k the derivative of f of t as a Fourier transform j omega over the power of k into f of omega. So these points always you have to keep in the mind. So these points always you have to keep in the mind. Same thing we have discussed. So j omega over the power of k into f of omega. So if you remember the Laplace transform formula, it is very simple to derive this one also. So now the next concept is triangular pulse. Suppose if you have a triangular pulse in the time domain, how to get the Fourier transform in the frequency domain? What is the expression? So this is a triangular pulse, right? This is a triangular pulse in the time domain. Here t is also minus t. So this is our peak value is 1. So now tell me from this what is the width here? This width is equal to 2t. And what is the area? Area is equal to half into base into height. Half into base is again 2t and height is 1. 2t cancels, we are going to get area is 2. What's the Fourier transform f of omega is equal to? You have to know the formula. Area into sa square of omega into width by 4. Area into sa square of omega into width by 4. Area is nothing but t and width is 2t. The substitute 2t by 4 is equal to t by 2. So t by 2. Area is t. Same thing. So you have to remember these formulas. In the case of rectangular pulse, what is the Fourier transform? which is area into saw of omega into width by 2. In the case of the triangular pulse, we can say triangular pulse, the Fourier transform is area into saw square of omega into width by 4. So these things always you have to keep in your mind. So let me write the formulas so that you can easily able to understand. Suppose if it is a rectangular pulse. Suppose if it is a rectangular pulse, what is the Fourier transform? F of omega is equal to the area into saw of omega into width by 2. Suppose if it is a triangular pulse, then what is the f of omega? F of omega is equal to area into saw square of omega into width by 4. Width by 4. So this one I already told you so many number of times. Sampling function. Sampling function. So this one you have to keep in your mind. So saw of x is equal to sin x by x. And I've already told you sin of x is equal to sin pi x by pi x. These formulas already I have told you. So now the next thing is, the next property is the multiplication by t. So suppose what happens if you, for a given signal f of t, if multiply by t, then what happens to the Fourier transform that we are going to study. So for f of t, the Fourier transform is f of omega. Then t into f of t as a Fourier transform, j into df of omega by t omega. So this one you have to keep in your mind. So therefore we can say, for f of t as a Fourier transform f of omega, for t into f of t as a Fourier transform, j into d of f of omega by d omega. So let me conclude here also. So I already told you, for f of t, if the Laplace transform is f of s, then for t to the power of n into f of t as a Laplace transform, and also only the power of n into the nth derivative of s with respect to f of s. So the nth derivative of f of s with respect to s. Suppose what I will do, then t into f of t. So t into f of t means what I can write here, minus 1 over the power of 1 is minus 1 into t by ds of f of s. Here s is equal to j omega. S is equal to j omega. So j I can take it outside here. So it will become minus d of f of s by j comes out with this d omega. So minus 1 by j. This multiply by j and divide by j. J square is equal to minus concepts are going to get j. So d into f of s by d omega. In place of s write omega. Then what we are going to get? J into df of omega by d omega. So that's it. So same thing we have got here. So t into f of t as a Fourier transform j into df of omega by d omega. So if you remember this formula, the Laplace domain formula, the Fourier transform is very simple. If f of t has a Fourier transform, the Laplace transform f of s, then t to the power of n into f of t has a Laplace transform, and as well as the power of n into n the derivative of f of s with respect to s. So in place of n I substitute 1. So t into f of t has a Laplace transform minus 1 into df of s by ds. So what I will do, in place of s I will substitute j omega. So j is a constant, we can take it outside is the derivative. So minus 1 by j you are going to get. So this thing is divide by j, multiply by j and divide by j. J into j is j square. Minus to minus is plus. So plus j we are going to get. So plus j into d of f of omega by d omega. In place of s I write omega. So you are going to get this one. So t into f of t has a Fourier transform j into df of omega by d omega. This is what we are for. So now let's go for the another thing. See, as I've already told you. So now what I will do? I will do one important thing. So e to the power of n into u of t. I've already told you the formula. E to the power of n into u of t. I've already told you what's the Fourier transform. See, basically these things I've already told you, but let me repeat here. So e to the power of n into u of t is a Laplace transform, you know, n factorial by as the power of n plus 1. So listen carefully. So for t to the power of n into u of t as a Laplace transform n factorial by as the power of n plus 1. So what I will do, I will multiply by e to the power of minus 80 for this function. Then in place of this substitute s plus a. So n factorial by s plus a whole to the power of n plus 1. If you want Fourier transform, replace s by j omega. So n factorial by a plus j omega whole to the power of n plus 1. Same formula. So therefore, e to the power of n into u of t as a Laplace transform, which is n factorial by the power of n plus 1. So e to the power of minus 80 into this one is nothing but wherever s is there equals s by s plus a. We are going to get this Laplace transform. But we want Fourier transform, right? So in place of s substitute j omega, we are going to get the Fourier transform. So now e to the power of minus pi t square. The Fourier transform we have to remember, which is e to the power of minus omega square by 4 pi. This one you have to keep in your mind. So e to the power of minus pi t square. The Fourier transform is e to the power of minus omega square by 4 pi. This one you have to keep in your mind. So for one, the Fourier transform is 2 pi into delta of omega. So for one, the Fourier transform is 2 pi into delta of omega. So for one, we are going to get the Fourier transform, which is 2 pi into delta of 1. 2 pi into delta of omega. So for u of t, what is the Fourier transform? For u of t, the Fourier transform is, we are going to get like this. Pi into delta of omega plus 1 by j omega we are going to get. So for u of t, the Fourier transform is pi into delta of omega plus 1 by j omega. This one already I have told you. So u of t is a Fourier transform pi into delta of omega plus 1 by j omega. And for cos omega naught t, what is the Fourier transform? So cos omega naught t means e to the power of j omega naught t minus e to the power of minus j omega naught t by 2. So for this, if you apply the Fourier transform, then what you are going to get? Simply, you know, for e to the power of j omega naught t, what is the Fourier transform? For e to the power of j omega naught t, what is the Fourier transform? Say, listen, let me write here. So let me write here so that you can easily able to understand. So cos omega naught t means e to the power of j omega naught t minus e to the power of minus j omega naught t by 2. So 1 by 2 I will take it outside. E to the power of j omega naught t minus e to the power of minus j omega naught t. See, I have already told you f of t into e to the power of minus j omega naught t. What is that? Let me write here. So for this one, what is that? For Fourier transform f of omega plus omega naught. Suppose f of t into e to the power of plus j omega naught t as a Fourier transform f of omega minus omega naught. Here plus means here minus, minus means here plus. So now in this case, suppose what I will do, for delta of t, the Fourier transform is 1. You know. So for e to the power of minus j omega naught t, what will the Fourier transform? What I will do? Basically, so what I will do, for delta of t, the Fourier transform is 1. For delta of t, the Fourier transform is 1. And so for delta of t, the Fourier transform is 1. So now what I will do, very simple, e to the power of minus j omega naught t and e to the power of plus j omega naught t. So these formulas you have to keep in your mind. So what I will do very simple. So now what I will do is very simple, that so f of t, and this is the thing. So for delta of t, the Fourier transform is nothing but 1. For delta of t, what is the Fourier transform? We are going to get 1. And I already told you, one more important point. What is that thing? So just forget this one. Delta of t plus t0. What is the delta of t plus t0? You know what is the Fourier transform? E to the power of j omega t0. So t0, right? So t0. So this one already you have to keep in mind. And delta of t minus t0 as the Fourier transform e to the power of minus j omega t0. This one already I have already told you. These important formulas already I have told you. So now basically I want to find what is a Fourier transform for this one. This one I want to find. It is a Fourier transform of this one. This one is nothing but simply I can say that. So for delta of t, which is 1. For what I will do. So suppose if f of t is 1. So for 1 means 2 pi into omega. So listen carefully. What I will do very simple. Suppose for 1, what is the Fourier transform? 2 pi into delta of omega. Which then f of t is 1. So now 1 into e to the power of minus j omega naught t. What is the Fourier transform? Fourier transform is nothing but inverse of omega, substitute omega plus omega naught. So 2 pi into delta of omega plus omega naught. Similarly, e to the power of plus j omega naught t has the Fourier transform 2 pi of delta of omega minus omega naught. So substitute here. So this Fourier transform, right? So 2 pi into 2 pi common. It will become delta of omega plus omega naught minus delta of omega minus omega naught by 2. So 2 cancels, we are going to get pi into delta of omega plus omega naught minus delta of omega minus omega naught. So this is what we have proved. So you have to remember these things. Actually, f of t into e to the power of minus j omega naught as a Fourier transform f of omega plus omega naught, and f of t into e to the power of plus j omega naught as a Fourier transform f of omega minus omega naught. So now, just don't remember these things. Don't remember these things. So for one, we know the Fourier transform is 2 pi delta of omega. So suppose f of t is 1. So 1 into e to the power of minus j omega naught t as a Fourier transform f of omega plus omega naught means replace omega by omega plus omega naught. E to the power of plus j omega naught plus replace omega by omega minus omega naught. So now, for this one we know Fourier transform, therefore this one also we know the Fourier transform. Just subtract and divide by 2. So we know these two values we have got and divide by 2. So therefore we got 2 cancels, we are going to get 5. Same thing. So this is what that we got. For sin omega naught t is same thing. Sin omega naught is nothing but e to the power of j omega naught t minus e to the power of minus j omega naught t by 2j. Just now we have discussed the Fourier transform of e to the power of j omega naught t and e to the power of minus j omega naught t. Just subtract and divide by 2j. Then we are going to get pi by j into delta of omega minus omega naught minus of omega plus omega naught. So this is what that we are going to get. So these formulas always you have to keep in your mind. So if you know this formula, for one, the Fourier transform is 2 pi delta of omega, and another formula which is f of t into e to the power of plus or minus j omega naught as Fourier transform f of omega minus plus. So you have to remember this formula, which is for one, the Fourier transform is 2 pi into delta of omega, and for f of t into e to the power of plus or minus j omega naught t is a Fourier transform f of omega minus plus omega naught. Plus means here minus, here minus means here plus. So with the help of this we have got this one. So now same thing here. Delta of the Fourier transform is 1. For 1, the Fourier transform is 2 pi into delta of omega. So for delta of the Fourier transform is 1. For 1, the Fourier transform is 2 pi into delta of omega. For e to the power of j omega naught t, just now we have discussed, right? For e to the power of j omega naught t, the f of t is 1. So replace omega by omega minus omega naught. So 2 pi delta of omega minus omega naught. And delta of t minus t naught, this we have discussed, right? Time shifting. Here, what will be the formula? So I have already told you the formula for f of t plus or minus t naught as the Fourier transform, which is f of omega into e to the power of plus or minus j omega t naught. So plus means here plus, here minus means here minus. So here minus means you have to keep it minus j omega naught t naught. And here delta, right? So f of omega is 1. So 1 into e to the power of minus j omega t naught. So what is cos omega naught t? Just now we have discussed it. Cos omega naught t means just now we have discussed the formula. Same thing we have written. For delta, so now you know delta of t plus t naught and you know delta of t minus t naught. These two have had it. So then you know for this one, for delta of t plus t naught, what is the Fourier transform? The Fourier transform is e to the power of plus j omega t naught. So if we have these two signals, then add the corresponding Fourier transform also, then what are you going to get? 2 cos omega t naught we are going to get. So if you know the basic formulas, getting this is a very piece of cake. This one we have to keep in your mind. Now we are going to discuss another point, which is suppose for duality. So duality principle that we are going to study. So for f of t as a Fourier transform f of omega, then we can say that what's the meaning of duality? Capital F of t as a Fourier transform 2 pi into f of minus omega. So what is the meaning of duality? Duality means like this one. So like this. Suppose if the frequency domain signal, if the same waveform, if it is going to be within the time domain, then what is the expression for the corresponding frequency domain that we need to figure out? Just 2 pi into f of minus omega. So for a small f of t, if it is as a Fourier transform capital f of omega, then capital f of t as a Fourier transform 2 pi into small f of minus omega. So these points always you have to keep in your mind. So small f of t as a Fourier transform capital f of omega, then capital f of t as a Fourier transform 2 pi into small f of minus omega. So what is the meaning of this one? Suppose whatever the waveform, the frequency domain, suppose if the same waveform is going to be in the time domain, then what is the corresponding Fourier transform that we need to figure out? Is 2 pi into small f of minus omega. The scaled version of this one, scaled version of this time domain signal, the scaled version of this time domain signal. So suppose here in place of f of omega, I will write here f of small f. frequency. Then here it will be capital F of minus f. That's it. So this one you have to keep it small f of minus f. So this one you have to keep in mind. This is in terms of omega. If you want in the terms of frequency, this is the formula. Capital F of f and here small f of minus f. That's it. This is in terms of omega. This is in terms of frequency, small f. So f of t has a Fourier transform f of small f of t has a Fourier transform capital F of omega. Then capital F of t has a Fourier transform theta into f of minus omega. Same thing here. Suppose if I write in terms of f means capital F of f here small f of minus f. So what is the meaning of this one? Suppose some signal it has some Fourier transform another signal. The signal 1 has a signal 2. So this is a signal 2 in the Fourier transform. If the same signal if it is appearing in the time domain, then this signal is going to appear in the frequency domain with some scaling. So therefore we can see clearly here, if this signal is going to appear in the time domain, then this signal is going to appear in the frequency domain with some scaling factor. Here f of omega is capital F of omega is here 2 pi into f of minus omega. In capital F of f is here small f of minus f. That's it. If this signal is going to come in the time domain, then this signal is going to come in the frequency domain. So what is the meaning of this one? If the frequency domain signal is appear in the time domain, then the time domain signal will appear in the frequency domain. That's it, interchanging. If the frequency domain signal, if it is appearing in the time domain, then the time domain signal will appear in the frequency domain. That is the meaning. So this formula you have to keep in your mind. So you know the Fourier transform of f of t, which is f of omega is equal to integration of t is equal to minus mt plus mt f of t d to the power of minus j omega t into dt. So this is called as the Fourier transform of the signal f of t. So now what I will do, in place of omega I will substitute 0. Then what is going to happen? Then this value is 1. So 1 into f of t is f of t. So f of 0 is equal to integration of t is equal to minus 2 infinity plus mt f of t dt. So what is the meaning of this one? This is very simple, that the area under the signal f of t dt is nothing but f of 0. So at omega is equal to 0, what is the Fourier transform is going to indicate the area under the f of t graph. So the area under the f of t graph is nothing but it is simply equal to, at omega is equal to 0, see what is the Fourier transform value, and that itself is nothing but it is the area under the curve f of t. So we can say the area under the time domain signal is nothing but in the frequency domain. If you see the value at omega is equal to 0, whatever the Fourier transform value, that is nothing but the area under the signal f of t. So therefore we can say finally, in the Fourier transform, I will substitute omega is equal to 0, then we are going to get f of 0 is equal to integration of t is equal to minus f to plus mt f of t into dt. It indicates that the area under the f of t is nothing but at omega is equal to 0, whatever the value of the Fourier transform, that value is nothing but the area under the signal f of t. So finally, the area under the signal, the time domain, it is nothing but it is equal to in the frequency domain, see the value at omega is equal to 0, that value is nothing but the area under the time domain signal. So at omega is equal to 0, whatever the Fourier transform value that we are going to get, that value is nothing but the area under the time domain signal. So now go about the reverse procedure. F of t is equal to 1 by 2 pi integration of omega is equal to minus mt plus mt f of omega into e to the power of j omega t into d omega. Suppose if you know f of omega, how to get the value of f of t, this expression I have already told you. This is called the inverse Fourier transform and this is called the Fourier transform. So in place of t I will substitute 0. Then what I am going to get? So this value you are going to get 1, right? In place of t I substitute 0. So this value we are going to get 0, 1. So 2 pi multiply here. So 2 pi into f of 0 is equal to integration of omega is equal to minus mt plus mt f of omega into d omega. So what is the meaning of this one? The area under the frequency curve means the area under the frequency curve is nothing but 2 pi into f of 0. So this is the area under the time domain signal. This is the area under the frequency domain signal. So this is the area under the time domain signal and this is the area under the frequency domain signal. So if you want the area under the time domain signal means in the Fourier transform, see the value at omega is equal to 0. Suppose if you want to find the area under the frequency domain curve, then it is nothing but 2 pi into f of 0 means here f of 0 means at t is equal to 0, see the value and multiply by 2 pi in order to get the area under the frequency domain curve. So this is what you have to keep in your mind. So by this expression we can get the area under the time domain signal, and by this expression we can get the area under the frequency domain signal. Here dt means substitute omega is equal to 0. Here d omega means substitute t is equal to 0. Very simple. The dt means substitute omega is equal to 0. Here at d omega means substitute t is equal to 0. Very simple to remember. So from this we can get the area under the time domain signal. From this we can get the area under the frequency domain signal. So now, you know what is the energy expression, you know. See, for f of t there will be f of omega. So for f of t there will be f of omega. So the energy in the time domain should be equal to energy in the frequency domain also. So for f of t, the energy in the time domain should be equal to energy in the frequency domain also. So both the curves. So you can say for f of t, so f of t is going to give you, it is going to give you f of omega. So this signal has some energy E. Its corresponding Fourier transform is also, it will have the same amount of energy E. So what is that? We need to figure out. So E is equal to integration of t is equal to minus into t f of t whole square dt. So this we know the expression of the energy in the time domain. But if you want to write in the terms of frequency domain, which is 1 by 2 pi integration of omega is equal to minus into t mod of f of omega whole square to omega. So this is called as a Parseval's equation. So 1 by 2 pi integration of omega is equal to minus into t mod of f of omega whole square to omega. So from this we can get the energy, whatever the energy present in f of t should be equal to energy present in the f of omega also. So E is equal to integration of t is equal to minus into t f of t whole square dt is equal to 1 by 2 pi integration of omega is equal to minus into t mod of f of omega whole square to omega. So this is the expression of the energy in the time domain and this is the expression of the energy in the frequency domain. This is called as a Parseval's theorem, or Parseval's equation also we can say. So finally, whatever the energy in the f of t must be equal to energy in the frequency domain also. So E is equal to integration of t is equal to minus into t mod of f of t whole square dt is equal to 1 by 2 pi integration of omega is equal to minus into t mod of f of omega whole square d omega. So this formula you always have to keep in your mind. This is called as a Parseval's equation. So same thing I have rearranged like this. See, as I already told you, these two are same. First two terms are same. Basically, the Markov spectrum is an even spectrum. It is an even spectrum. So whatever the graph from omega is equal to 0 to infinity, same graph we are going to get from 0 to minus infinity also. So what I will do, instead of going from minus infinity to plus infinity, I will go from 0 to infinity and I will multiply by 2. So therefore what you are going to get, simply we are going to get like this. So we are going to get like this. I can write like this. 1 by 2 pi into 2 times of integration of omega is equal to 0 to infinity mod of f of omega whole square d omega. So 2 cancels, we are going to get 1 by pi integration of omega is equal to 0 to infinity mod of f of omega whole square d omega. Suppose what I will do, suppose if I want to write in terms of frequency, then what I will do, omega is equal to 2 pi f, so d omega is equal to 2 pi into df. So 2 pi 2 pi cancels, we are going to get this expression. So in place of f this is the expression. So you can see clearly that omega is equal to 2 pi f. Suppose if omega is equal to minus infinity means f is also equal to minus infinity. If omega is equal to plus infinity means f is also equal to plus infinity. And d omega is nothing but 2 pi into df. So d omega is equal to 2 pi into df. So substitute df. So 2 pi 2 pi cancels. We are going to get this expression there. So this is another way of writing in terms of frequency f. But if you want to further simplify this, in place of minus into plus infinity, I will take from 0 to infinity and multiply by 2. Here also in place of minus into plus infinity, I will take f is equal to 0 to infinity, so I multiply by 2. So these are the different ways of writing. So this is the thing we have to keep in your mind. So if you know this one, with the help of this concept, you can even get this one. So you have to remember this basic equation. This is equal to integration of t is equal to minus into plus infinity mod of f of t whole square dt is equal to 1 by 2 pi integration of omega is equal to minus into plus infinity mod of f of omega whole square d omega. So this is called the Parseval's equation. So suppose in place of omega I have substitute 2 pi f. As omega is equal to minus infinity, f is also equal to minus infinity. As omega is equal to plus infinity, f is also equal to plus infinity. And d omega is equal to 2 pi into df. So 2 pi 2 pi cancels, we are going to get this expression. So by this we can get the energy in the signal f of t or the energy in the signal f of omega. Both the energies are same. So now let's go for the another property, which is a convolution property. Suppose f of t has a Fourier transform f of omega, then h of t has a Fourier transform h of omega. Suppose if the signal p of t is a combination of these two signals, then their corresponding Fourier transform is nothing but the convention time domain will use to product in the frequency domain. So f of omega into h of omega. So p of omega is equal to f of omega into h of omega. So convolution in time domain will leads to the product in the frequency domain or the Fourier transform domain. So instead of doing a convolution, it will take a lot of time. Instead of that, like do that multiplication of the Fourier transform, and with the help of inverse Fourier transform, we can get the time domain expression. So this will take very less amount of time when compared to this one. So that is the reason I told you, whenever you go from chapter 1 to chapter 5 in the signal and system course, the amount of calculation is going to get reduced while deriving the solution. So for f of t as a Fourier transform f of omega, and h of t is the Fourier transform h of omega, then p of t, which is nothing but convolution of these two signals, then the corresponding Fourier transform is p of omega is equal to f of omega into h of omega, means the convolution and time domain will use to product in the frequency domain of Fourier transform domain. So this is the LTI system. For this LTI system, the input response is h of t and the input is f of t, and the output y of t is equal to f of t convolution of h of t. So now I will try to find the Fourier transform of each and every signal. So f of t Fourier transform is f of omega, and h of t Fourier transform is h of omega. Then for y of t, the Fourier transform is y of omega, which is nothing but the multiplication of these two things, which is f of omega into h of omega. So the convolution of time domain will be used to collect in the frequency domain. So y of t is equal to f of t convolution of h of t, and y of omega is equal to f of omega into h of omega. This one you have to keep in your mind. Now the next thing is convolution property in the Fourier transform. Suppose in the frequency domain, suppose if the convolution is going to happen in the frequency domain, then what will happen in the time domain? It is multiplication, vice versa. See, convolution time domain will use to multiplication in the frequency domain. Similarly, the multiplication time domain will use to convolution in the frequency domain, vice versa. So, if f of t has a Fourier transform f of omega, and h of t has a Fourier transform h of omega, then f of t into h of t has the Fourier transform 1 by 2 pi into f of omega convolution of h of omega. As I already told you, convolution in time domain will use to multiplication in frequency domain. Similarly, multiplication in the time domain will use to convolution in the frequency domain. So f of t has a Fourier transform f of omega, and h of t has the Fourier transform h of omega. Then f of t into h of t has the Fourier transform 1 by 2 pi into f of omega convolution of h of omega. So this formula always you have to keep in your mind. So now the next thing is integration concept that we are going to learn. So for f of t, if the Fourier transform is f of omega, then what is the integration of the signal f of t? What is the integration of the signal f of t? See, I have already told you, we can write integration is nothing but f of t convolution of u of t. This one I already told you so many number of times. See, f of t convolution of u of t is nothing but it is the integration of the signal from t is equal to minus infinity to f of tau d tau. So here, this is the integration of the signal, right? This is the integration of signal of f of t convolution of u of t. Then what is the Fourier transform? It will become f of omega into u of omega. So for f of omega into, so you know the Fourier transform of u of t. What is the Fourier transform of u of t? Which is, we can say pi into delta of omega plus 1 by j omega. So this is the formula for the u of t. This formula already I have discussed in the class, so that we have to keep in your mind. So therefore we can say for u of t, what is the Fourier transform? Which is pi into delta of omega plus 1 by j omega. So multiply now inside. So we are going to get f of omega by j omega plus f of omega into pi into delta of omega. Delta of omega is defined only for omega is equal to 0 only. So therefore, in place of f of omega, now you have to multiply, you have to keep it omega is equal to 0 because delta of omega is defined only at omega is equal to 0. So therefore, you have to keep the f of 0. So f of omega by j omega plus pi into capital F of 0 into delta of omega you are going to get. So this is what that we are going to get. F of omega by j omega plus pi into f of 0 into delta of omega. Suppose, assume a special case. Suppose f of 0 is nothing but this one we have discussed, right? F of 0 is nothing but this one we have discussed. F of 0 is nothing but capital F of 0 is equal to integration of t is equal to minus into x to f of t dt. Suppose if this value is equal to 0, means area under the time domain graph is equal to 0, then f of 0 is also equal to 0, then this will be ruled out, only this one is going to be present. So this is a special case. When f of 0 is equal to 0, then this will go out, and only this part you are going to get, which is f of omega by j omega we are going to get. So you know f of 0 is equal to integration of t is equal to minus into percent f of t into dt. So this value, suppose if this value is equal to 0, then this value will rule out, only this one we are going to get. So what's the meaning of this one? The area under the time domain graph is equal to 0, then f of 0 is equal to 0. So we are going to get this one. So this is what we have to keep in mind. So all these properties I have already discussed very detailed, but still finally I have given a summary of these things. So all these things you have to keep in mind. we are going to discuss the another important point, which is the Laplace transform is going to exist when the f of t into e to the power of minus sigma t is absolutely integrable. This one I have already told you, right? So the Laplace transform is going to exist only when f of t into e to the power of minus sigma t is absolutely integrable. So what is the meaning of this one? Suppose if the function f of t into e to the power of minus sigma t is absolutely integrable, then only we can say the Laplace transform is going to exist. Then Fourier transform is going to exist when f of t is absolutely integrable, and Z transform is going to exist when f of n into r to the power of minus n is absolutely integrable. See, I have already told you Z is nothing but Z is equal to e to the power of s, as I have already told you. S is equal to sigma plus j omega. So if we simplify, we are going to e to the power of sigma into e to the power of j omega. E to the power of sigma is nothing but r into e to the power of j omega. So here in place of e to the power of sigma, I can write r to the power of minus whole t. So in the discrete domain, replace t by n. So we are going to get minus n. Same thing, here t is replaced by n. So therefore, f of n into r to the power of minus n. So if you know this one, we can get this one with the help of this notation, that is called e to the power of s. So therefore, we can say that when f of t into e to the power of minus sigma t is absolutely integrable, then only the Laplace transform is going to exist. Similarly, if f of t is absolutely integrable, then the Fourier transform is going to exist. Similarly, if f of n into r to the power of minus n is absolutely integrable, then the Z transform is going to exist. So these points always you have to keep in your mind. So therefore, we can say that finally, when f of t into the power of minus sigma t is absolutely integrable, then the Laplace transform is going to exist. If f of t is absolutely integrable, then the Fourier transform is going to exist. If f of n into r to the power of minus n is absolutely, actually we should say we are summable, discrete domain, right? We should write here absolutely summable. Here we have to write absolutely summable. So absolute, because discrete term, so here we have to write summable, not integrable. So when f of n into r to the power of minus n is absolutely summable, then the Z transform is going to exist. So finally, I can say that when f of t into e to the power of minus sigma t is absolutely integrable, then the Laplace transform is going to exist. And when f of t is absolutely integrable, then the Fourier transform is going to exist. And when f of n into r to the power of minus n is absolutely summable, then the Z transform is going to exist. So these things always you have to keep in your mind. So now we will discuss the notations. And notations I have already given, which is Z is equal to e to the power of s. S is equal to sigma plus j omega. So if we simplify, we are going to get e to the power of sigma into e to the power of j omega. So e to the power of sigma is nothing but r. So r into e to the power of j omega, that we are going to get, which is Z is equal to r into e to the power of j omega. So now let's go for the another point. Suppose for f of t, if you apply the Fourier transform, we are going to get f of omega, which is equal to integration of t is equal to minus m to plus m d, f of t into e to the power of minus j omega t into dt. This formula already I told you. Suppose for f of t, if we are going to apply the Laplace transform, then we are going to get f of is equal to integration of t is equal to minus m to plus m d, f of t into e to the power of minus s t into dt. Similarly, for f of n, if we are going to apply Z transform, then we are going to get f of z is equal to sigma n is equal to minus m to plus m t, f of n into z to the power of minus n. So these three formulas always you have to keep in mind. So if you know the Laplace transform, getting the Fourier transform is a very piece of cake. Just replace s by j omega. This one I have already told you, right? So the number of times. So therefore we can say f of t, or f of the Fourier transform f of omega is equal to integration of t is equal to minus m to plus m t, f of t into the power of minus j omega t into dt. And for f of t, if you are going to apply the Laplace transform, then the f of s that you are going to use is integration of t is equal to minus m to plus m t, f of t into e to the power of minus st into dt. And similarly, f of n, if you apply the transform, we are going to get f of z is equal to sigma n is equal to minus m to plus m t, f of n into z to the power of minus n. So these things always you have to keep in your mind. So finally, I can say for f of t, if you are going to apply the Fourier transform, then we are going to get f of omega is equal to integration of t is equal to minus m to plus m t, f of t into e to the power of minus j omega t into dt. So for f of t, if you are going to apply the Laplace transform, then we are going to get f of s is equal to integration of t is equal to minus m to plus m t, f of t into e to the power of minus st into dt. And for f of n, if you are going to apply the Z transform, then we are going to get f of z is equal to sigma n is equal to minus 70 plus 70 f of n into z to the power of minus n. So these formulas always you have to keep in mind, and I have already told you e to the power of s is nothing but z. So here z to the power of n plus t by n. So n minus n, f of n integration by plus by sigma, then we are going to get sigma n is equal to minus 70 plus 70. So see, if you know the Laplace transform, then you can get the Fourier transform just by replacing s is equal to j omega. So just to if you know the Laplace transform, getting the z transform is also very simple case, which is replace e to the power of s by z and replace t by n and integration by summation. That's it. This is something you have to keep in your mind. So now the next important point is, I've already told you, if you know the Fourier, if you know the Laplace transform, in the place of Laplace transform we substitute s is equal to j omega, then we are going to get the Fourier transform with signal f of t. So this is a very important thing, which is, say, if you know the Laplace transform, in the place of s, if you substitute j omega, then we are going to get the Fourier transform. This one I have already told you so many number of times. So therefore, in the case of Laplace transform, if you replace s is equal to j omega, then we are going to get the Fourier transform. So see, in the place of s, if you substitute j omega, the sigma is equal to 0, so purely on the imaginary axis, then we are going to get the Fourier transform. So therefore, finally I can say, for the Laplace transform, if you replace s is equal to j omega, then we are going to get the Fourier transform with signal f of t. So Fourier transform is a particular case of the Laplace transform. Is, see, Laplace transform is nothing but s is equal to sigma plus j omega. If sigma is equal to 0, then only we are going to get the Fourier transform. So therefore we can say the Fourier transform is one of the special case of the Laplace transform. So Fourier transform is a particular case or the special case of the Laplace transform, because when sigma is equal to 0, the Laplace transform and the Fourier transform, they are going to get coincide, because they are equal. Otherwise they are not equal. So therefore we can say that the Fourier transform is one of the case or the special case of the Laplace transform. So Fourier transform is a particular case or a special case of the Laplace transform. Only when sigma is equal to 0, both the Laplace transform and the Fourier transform, they are going to get coincide. Otherwise they are not coincide. So therefore we can say that the Fourier transform is a particular case or the special case of the Laplace transform. So the next thing is, if f of t they have given, then first thing what you have to do, which is integration of t is equal to minus 70 plus 70 mod of f of t into the power of minus sigma t less than infinity for a few range of sigma called as the ROC. So I've already told you, suppose they have given some signal f of t, and I've already told you, if you want the Laplace transform to obtain, then the f of t into the power of minus sigma t must be absolutely integrable. If it is absolutely integrable, then only we can say the Laplace transform is going to get exist. This happens only for a few range of the sigma, that is called as the ROC. That is called as the ROC. So f of t into the power of minus sigma t is absolutely integrable only for some range of sigma, that is called as the ROC. That is called as the ROC. So s is equal to sigma plus j omega, and the real part of s is called as the sigma, and the imaginary part of s is called as the omega. So real part of s is nothing but sigma, which is called as the ROC. So this is a very important statement. Always you have to keep in mind. So as I've already told you, which is when f of t into the power of minus sigma t is absolutely integrable, then only we can say the Laplace transform is going to get exist for a function f of t. This happens only for a few range of the sigma, that is called as the ROC, which is s is equal to sigma plus j omega. Sigma is called the real part of the s, and omega is called as the imaginary part of the s, and the real part of s is nothing but sigma, which is called as the ROC, which is called as the ROC. So finally I can say, suppose some signal f of t they have given. Now if you want for the signal, if you want the Laplace transform to exist, then first you have to check, which is f of t into the power of minus sigma t, is it absolutely integrable or not. It is going to absolutely integrable only for a particular range of sigma. That sigma is called as the ROC. That sigma is called as the ROC, whereas s is equal to sigma plus j omega, where sigma is called the real part of the s and omega is called as the imaginary part of the s, and the real part of s, which is called as the sigma, which is basically the ROC. Only for a few range of sigma, this Laplace transform is going to get exist, because this absolute is going to decide integration. This is absolutely integrable. So now the next thing is, suppose if f of n they have given, so then what you have to do, then I've already told you, if you want the z transform to exist for the signal, then the f of n into r to the power of minus n should be absolutely summable. Then only we can say that the z transform is going to get exist. this is going to give a finite value only for a few range of R. That is called as the ROC. That is called as the ROC. And I've already told you Z is equal to e to the power of S. S is equal to sigma plus j omega. So if we simplify, we are going to get e to the power of sigma into e to the power of j omega. E to the power of sigma is nothing but R. So Z is equal to R into e to the power of j omega. And magnitude of Z is nothing but R, which is called as the ROC. So the magnitude of Z is nothing but R, and the phase angle of Z is nothing but omega. So therefore we can say that suppose some discrete time signal f of n they are given. So if you want the Z transform to exist for this signal, then what you have to do, basically we have to do the f of n into r to the power of minus n. If it is absolutely incurable, this is only possible only for a few range of r. That is called as the ROC. And I have already told Z is equal to e to the power of S. S is equal to sigma plus j omega. So if we simplify, we are going to get e to the power of sigma into e to the power of j omega. And e to the power of sigma is nothing but r. So Z is equal to r into e to the power of j omega. And the magnitude of Z is equal to r. And the phase angle of Z is equal to omega. So what is the ROC? The ROC is nothing but the magnitude of Z is equal to r only for a particular range of r. If this is going to get the absolute, if this is going to get the absolutely summable, or absolutely summable is going to happen only for a few range of r. That is called as the ROC. So finally, I can say in the case of time domain, the ROC is nothing but sigma. In the case of discrete domain, the ROC is nothing but the radius. So finally, I can say in the case of time domain, the ROC is nothing but sigma, which is real part of S. And in the case of Z transform, the ROC is nothing but the amount of Z, which is R. So these things always you have to keep in your mind. So now let's go for the another important formula, which is A plus AR plus AR square up to infinite number of terms. It is equal to A by 1 minus R when only the magnitude of R is less than 1. The magnitude of R is less than 1. So this formula is applicable only when the magnitude of R is less than 1. So what is the meaning of this one? What is the meaning of this one? If the magnitude of R is less than 1 means this value goes on decreases. This is sum. So finally the terms number is going to get decreases, and finally you are going to get a final value which is A by 1 minus R. Even if you forget this formula, still we can get, in the case of the geometric series, I have already told you AR up to A into R to the power of n minus 1. So as I have already told you, what is their sum? I have already told you what is their sum? A plus AR plus up to A to the power of, let's go for A to the power of n only. We can take like this, okay? Let me take like this. The summation is equal to, first one is A, 1 minus R to the power of, total number of terms are here. See, it is 1, then R square, then R cube up to R to the power of n. Total number of terms are n plus 1. So n plus 1 by 1 minus R. Suppose, if the value of R, the amount of R is less than 1, then what is going to happen? And n is equal to infinity. Then what is going to happen? Then A into 1 minus R is very, very less and n is very, very high. Suppose, small example, if R is half and n is infinity, this value is nothing but 0. So this is 0 by 1 minus R. So we are going to get A by 1 minus R. So this is a formula that we are going to get. So A by 1 minus R. I have already told you. So therefore A plus AR square to infinite number of terms is equal to A by 1 minus R. This formula is going to hold only for when the amount of R is less than 1. So this formula is going to hold only when the amount of R is less than 1. And I have already told you, which is the sum of GP, A plus AR square plus up to A to R to the power of n is equal to, the first term is A into 1 minus R to the power of, total number of terms are n plus 1 by 1 minus R. Suppose if you have infinite number of terms and the value of R is less than 1, then what I am going to get? Suppose R is equal to half, and n is infinity, then 1 by 2 all the power of n is nothing but 0. So this value will be 0. So 1 minus 0 is equal to 1. So 1 t is equal to A. So A by 1 minus R you are going to get. So therefore, this formula always you have to keep in your mind. So finite GP and infinite GP, these two formulas always you have to keep in mind, because these formulas are very much useful in the signal and system course. Suppose in the S plane, I have already told you in the S plane, S is equal to sigma plus j omega. And in the Z plane, Z is equal to e to the power of S. I have already told you Z is equal to e to the power of S. So as Z is equal to e to the power of S is equal to sigma plus j omega. So therefore e to the power of sigma into e to the power of j omega. E to the power of sigma is nothing but R into e to the power of j omega. So you can write in the polar format R at the angle of omega, R into e to the power of j omega. You can write in any fashion, any of the concept is same. So S is equal to sigma plus j omega. This is in the S plane, and Z is equal to R into e to the power of j omega. or r at phase angle of omega. R is nothing but e to the power of sigma. This is in the jet plane. And I already told you in the S plane, the ROC is the sigma, and in the jet plane, the ROC is the R. So this point already I have told you. So now the next concept is I am going to tell you the relation between the S plane as well as the jet plane. So basically, I am going to tell you the relation between the S plane as well as the jet plane. How to? Means we can say mapping the S plane to the jet plane. How to map? These things we are going to discuss. As I have already told you, R is nothing but e to the power of sigma. Just now we have discussed that R is equal to e to the power of sigma. Suppose when sigma is equal to 0, means the imaginary axis. We can say, suppose this is a S plane and this is a jet plane. So this is a S plane, this is a jet plane. So sigma is equal to 0 means imaginary axis. So if sigma is equal to 0, then what you are going to get R. R is equal to e to the power of sigma. Sigma is equal to 0, so e to the power of 0 is equal to 1. So therefore we are going to get R is equal to 1. So S is equal to sigma is equal to 0, so you are going to get only j omega. R is equal to 1. So 1 into the angle of omega. So all these points, all the points of the S plane, they are going to map on the unit circle of radius 1. So we can say all the points on the unit circle, all the points on the imaginary axis of the S plane, they are going to map to the unit circle on the jet plane. Suppose when sigma is equal to -1, means the LHS of the S plane, then what you are going to get? If you substitute R is equal to e to the power of sigma is equal to -1. E to the power of -1 is nothing but 1 by E. 1 by E is nothing but E is greater than 1. It's 2.2, 2.27 like that. So definitely 1 by anything greater than 1 is nothing but the ratio is less than, it is less than 1, we can say. 1 by E is nothing but it is less than 1. It is less than 1. It is less than 1. This value is less than 1. So what we can say? So all LHS are going to map inside the unit circle of the jet plane. So all of the LHS of the S plane, they are going to map inside the unit circle. So what is the S? S is equal to S sigma is -1. -1 plus j omega is equal to R is Z is equal to 1 by E into phase angle of omega. So all the LHS of the S plane, they are going to map inside the unit circle because 1 by E value is less than 1. Similarly, when sigma is equal to sigma 1, then what you are going to get? R is equal to the power of plus sigma 1. Then S is equal to sigma 1 plus j omega 1. Z is equal to the power of plus sigma 1 at an angle of omega. Same concept, right? Suppose when sigma is equal to -infinity, then what you are going to get? When sigma is equal to -infinity means you are going to get R is equal to the power of -infinity. E to the power of -infinity is nothing but 1 by the power of infinity, which is equal to 0. So S is equal to minus sigma plus j omega means nothing but Z is equal to 0 at an angle of omega means if any point which is lying and the negative, the LHS of a very infinite negative value, then it is going to point inside the point circle to become the point circle. We can say 0 radius. When sigma is less than 0 in S plane, it maps to inside the unit circle in the jet plane. Same thing I already told you. When sigma is less than 0, when sigma is less than 0 means all the LHS are going to lie inside the unit circle. They are going to lie inside the unit circle. So this is what we can see clearly here. When sigma is equal to 1, then what we are going to get? When sigma is equal to 1 means we are going to get R is equal to the power of 1, which is equal to E. So E is equal to 1 plus j omega, which is Z is equal to E into at an angle of omega. So therefore we can see E is greater than 1. So it is outside the unit circle. So all the arches of the S plane, they are going to map outside the unit circle. Suppose when sigma is equal to infinity, then we are going to get R is equal to the power of infinity, is equal to infinity. So S is equal to infinity plus j omega. So Z is equal to infinity at an angle of omega. So what I can say, the point which is present at infinity at the RHS is going to present far away from the jet plane with the radius of infinity. So when sigma is greater than 0, when sigma is greater than 0 in the S plane, it is going to map outside the unit circle in the jet plane. This one I have already told you. So therefore we can say that. So what I can say simply all the LHS. So all the LHS, listen carefully. Here I will write here. So this is the S plane and this is the jet plane. So all the LHS of the S plane, they are going to map inside. Unit circle. And all the points are present on the imaginary axis. They are going to map on the unit circle. And all the points which are present on the RHS of the S plane, they are going to map means outside the unit circle. It is going to map outside the unit circle. It's outside the unit circle. So this is the thing always you have to keep in your mind. So therefore, this thing you have to keep in your mind. Even if you forget the concept also, if you know it is equal to the power of s, then you can easily derive. So these things always you have to keep in your mind. So therefore we can say that all the LHS on the S plane, they are going to map inside the unit circle of the jet plane, and all the points of the imaginary axis of the S plane, they are going to lie on the unit circle, and all the points on the origins of the S plane, they are going to lie outside the unit circle. So these points always you have to keep in your mind. Always this one you have to keep in your mind. So finally, it will give you the graph. So that you can easily able to understand. Suppose this is a S plane. And this is a jet plane. So let me draw the graph so that you can easily able to remember this concept for large amount of time. So this is the S plane and this is the jet plane. Suppose I am moving from this side to this side. Suppose this is a unit circle. This is a unit circle. So as you are moving from here, so you will move in this direction. You will move from point circle to like this. Suppose if you are present here, then it will present here. Suppose if you move again to the origins of S plane, if you move here, then this will go here. So you can say clearly, whenever you move from this side to this side, the radius is going to increase from 0 to infinity. Listen carefully. Whenever you go from LHS to RHS like this, means when you walk from here, so suppose if I stand at infinity, at sigma is equal to minus infinity, and if I walk, then you have to stand like this. You have to stand here, and you have to move away like this. You have to move far away. So therefore you can say clearly, suppose if you are standing at sigma is equal to minus infinity, and if you are moving like this in this direction, then in the jet plane you have to go from at 0, you have to go in this direction away. So you can see as you come from minus infinity to sigma is equal to 0, then you will go from the point circle to unit circle. Similarly, if you go from sigma is equal to 0 to sigma is equal to infinity, then you will go from unit circle to infinite circle. So listen carefully. When you go from sigma is equal to minus 7 to sigma is equal to 0, then you will move from point circle to unit circle. Similarly, if you go from sigma is equal to 0 to sigma is equal to infinity, then you will move from unit circle to infinite circle. So this is a problem you have to keep in mind. So finally, I can say whenever you are moving from sigma is equal to minus 7 to sigma is equal to 0, then you are moving from point circle to unit circle. And if you are moving from point circle to infinity, from sigma is equal to 0 to sigma is equal to infinity, then you are moving from point circle to infinite circle. So the only thing that you have to keep in your mind, which is r is equal to e to the power of minus sigma. So if sigma is equal to minus infinity, then what is the value of r? R is equal to 0. If sigma is equal to 0, then r is equal to 1. If sigma is equal to infinity, then r is equal to infinity. Very simple, right? So therefore, whenever you are moving from sigma is equal to minus infinity to sigma is equal to 0, then you are moving from point circle to unit circle. If you are moving from sigma is equal to 0 to sigma is equal to infinity, then you are moving from unit circle to infinite circle. So these points always you have to keep in your mind. So now the next thing is, if you move left of S plane, then you will go inside the unit circle in jet plane. If you move right of S plane, then you will go outside the unit circle in the jet plane. Same thing everything. Suppose if you go like this, suppose if I stand here, and if I move in this direction, then you will go inside the unit circle. Suppose if I move in this direction, then I will move outside the unit circle. Very simple, right? See, suppose if I stand here, and if I move in this direction, then I will go inside the unit circle. Suppose if I stand here, and if I move towards the RHS, then I will go outside the unit circle. So simply I can say, whenever you are going to move from sigma is equal to minus 7 to sigma is equal to 0, then you are moving from point circle to unit circle. If you are going from sigma is equal to 0 to sigma is equal to infinity, then you are moving from unit circle to infinite circle. So this point always you have to keep in your mind. The next thing is, when sigma is lying from sigma 1 to sigma 2, then what is the z we are going to get mod z? Mod z is nothing but r. R is equal to e to the power of sigma. So e to the power of sigma 1 to e to the power of sigma 2. As sigma 1 is lesser than sigma 2, so e to the power of sigma 1 is also lesser than e to the power of sigma 2. So mod of z is nothing but r is going to lie from e to the power of sigma 1 to e to the power of sigma 2. So if sigma is lying from sigma 1 to sigma 2, then r is nothing but mod z, which is equal to e to the power of sigma. So e to the power of sigma 1 to e to the power of sigma 2. So mod of z is going to lie from e to the power of sigma 1 to e to the power of sigma 2. So when sigma is lying from sigma 1 to sigma 2, then mod of z is going to lie from e to the power of sigma 1 to e to the power of sigma 2. So these things always you have to keep in your mind. So what is the meaning of this one? So what is the meaning of this one? Let me tell you. So let me tell you what is the meaning of this one. Let me tell you the meaning. What is the meaning of that one? So let me go for the other picture. Suppose I will take this sigma 1 and this sigma 2. This is sigma 1 and this is sigma 2. I am going to consider. So only this range of sigma I am going to consider. So only this range of sigma I am going to get considered. So if I map all these points in a z plane, then what I am going to get? Here there will be a circle. So this is one circle, and here there will be another circle. So here there will be another circle. So this circle radius is, so this circle radius is nothing but, so here this circle radius is nothing but e to the power of sigma 1, and this circle radius is nothing but e to the power of sigma 2. So this is the mapping. So this is the mapping that we are going to get. So all these points are going to map in this z plane like this. So this is the meaning of this concept. So this is the meaning of this concept. So this is the meaning of this concept. So therefore we can say, whenever the sigma is lying from sigma 1 to sigma 2, means it is going to lie from e to the power of sigma 1 to e to the power of sigma 2. So all these points are going to map like this. Like this they are going to get mapped. So here rectangular strips, here angular strips. So this is the rectangular strips and this is the angular strips. So these points always you have to keep in your mind. So now we are going to discuss the other point. See, in synchronous systems, if ROC of the signal is completely right-sided, then only it is called as the right-sided signal. In synchronous system, if the ROC of the signal is completely left-sided, then the signal is called as the left-sided signal. This point I have already told you so many number of times. See, this concept I have already told you. Here let me tell you the signal and its corresponding ROC. So this is a signal. This is a signal and its corresponding ROC. So let me tell you the concept here. As I already told you, but let me repeat. Suppose if the signal is a right-sided signal. Right-sided signal means f of t is equal to 0 for t less than 0, then that is called as a right-sided signal. So for this signal, the ROC is towards the right side, Similarly, for left-sided signal means f of t is equal to 0 for t greater than 0, then for this signal, the ROC is toward the left side, Suppose if the given signal is a two-sided signal means f of t is not equal to 0 for the minus infinity plus infinity, those signals for two-sided signal. For this, the ROC is a rectangular strip or angular strip. So let's go for the rectangular strip I will tell you in the continuous time, in the Laplace domain I am telling you. Rectangular strip. Suppose if it is a finite duration signal. Finite duration signal means only for a certain amount of time. It is having a finite amount of amplitude, finite amount of duration. Then ROC is all over the S-plane, except sigma is equal to 0 or sigma is equal to plus infinity or sigma is equal to minus infinity, except these 3 points. So we can say finally, suppose if the given signal is a right-sided signal, then the ROC is toward the right side. If the given signal is a left-sided signal, means the ROC is toward the left side. And if the given signal is a two-sided signal, means the ROC is a rectangular strip. And if the given signal is having a finite duration signal, then ROC is all over the S-plane, except sigma is equal to 0 or sigma is equal to infinity or sigma is equal to minus infinity. So these points always you have to keep in your mind. So therefore, we can say finally So therefore, I can say finally that if the given signal is a right-sided signal, then the ROC is toward the right side. If the given signal is the left-sided signal, then the ROC is toward the left side. If the given signal is a two-sided signal, then ROC is a rectangular strip. If the given signal is a finite duration signal, then the ROC is all over the S-plane, except at sigma is equal to 0, or sigma is equal to plus infinity, or sigma is equal to minus infinity. So these things always you have to keep in your mind. So now, suppose this is the thing you have to keep in your mind. In Z plane means I have already told you. ROC in Z plane also I have already told you. So in Z plane means its right side means it will become outward. Outward is circle. Outward is circle. Here left side means inward is circle. Inward is circle. Rectangular strip means here it will be angular strip. Here it will be angular strip. Here all over the Z plane. All over the Z plane except Z is except we can say R is equal to 0 or R is equal to plus infinity. This one is point circle and infinite circle. So these things always you have to keep in mind. So finally, a given signal is called right-sided signal means f of t is equal to 0 for t less than 0. Then that is called as the right-sided signal. For this, the ROC is right side, the S plane, and output of a circle in the Z plane. If a given signal is a left-sided signal means f of t is equal to 0 for t greater than 0, then the ROC is toward the left side of the S plane and it is inward of a circle in the Z plane. If the given signal is a two-sided signal means f of t is equal to not equal to 0 for t less than or equal to plus infinity, then the ROC is a rectangular strip means between the two strips, 2 points, and also here it will be angular strips between the two circles. Or between the two, we can say sigmas, and between the two radius. Suppose if a given signal has a finite amount of duration, then the ROC is all over the S plane except at either at sigma is equal to 0 or plus infinity or minus infinity. Here is all over the Z plane except at point circle or infinite circle. So these things always you have to keep in your mind. This is what they have given. So if the ROC is toward the right side means it is a completely right side signal. If the we can say if it is a ROC is left side means it is a left side signal. So this is what they have given in this statement. So the signal system, if the ROC of a signal is completely right sided, then only it is called right sided signal. The signal system, the ROC of the signal is completely left sided, then the signal is called as a left sided signal. So now let's go for the another point. Suppose I have taken a system which has a memory. Suppose I have taken some system which has a memory. If the input is x of n and the output is y of n, how I am going to represent this one? So here, suppose in the discrete time domain, x of n will become x of z, y of n will become y of z, and memory is nothing but simply we can write h of z is equal to 2 to the power of minus 1. Why it is like this? Let us discuss. So let me assume y of n is called x of n minus 1. So this memory is the system is having some memory. So this is the relation between the input and output. Just y of n is equal to x of n minus 1. So if we substitute x is equal to n is equal to 0, we are going to get x of minus 1 is the doesn't output is determining what the positives of input. So basically it has a memory. So y of n is equal to x of n minus 1. So apply the z function on the both sides. Then what we are going to get y of z is equal to z to the power of minus 1 into x of z. So y of z is equal to the power of minus 1 into x of z. So y of z by x of z is nothing but is equal to the power of minus 1. So y of z by x of z, which is nothing but to the power of minus 1, which is nothing but h of z, which is nothing but s of z. So h of z is equal to the power of minus 1. So you can see clearly that y of z is nothing but y of z is equal to x of z into h of z. So therefore, h of z is equal to y of z by x of z, which is nothing but in this case to the power of minus 1. As I already told you, suppose x of n minus n naught as z transform to the power of minus n naught into x of z. Here minus means here minus, here plus means here also plus. This formula I want to show the number of times. Now let's go for the another thing. Suppose h of z is a function of z by function of z. Means it is basically like a rational number p by q format. If h of z is in the rational format p by q, it is the unit is a function of z, and the unit is also a function of z. If the degree of the numerator which is not equal to degree of denominator, then the given system is called as a causal system. See, if the degree of the numerator less than or equal to degree of denominator, then we can say it is a causal system. Suppose the degree of the numerator is greater than degree of denominator, then it is called as a non-causal system. See, this we need to remember. Basically, I told you this concept. I told you this concept in the system classes. But let me now I am going to tell you with the formulas. So you have to remember this statement. So that whenever the h of z is accumulated, it's a Laplace, it is a jet transform of the h of a impulse response. H of z is accumulated, it is a jet transform of the h of a. So it is a jet transform of the h of a. H of a is the impulse response of an engineering system. So h of z is equal to function of z by function of z. So if the degree of the numerator less than or equal to degree of the denominator, then only the given system is said to be a causal system. Otherwise it will be a non-causal system. Causal system is, I have already told you what is the meaning of causal system. Causal system means the output is going to, causal system is the output is independent of the future values of the input. Non-causal system is the output is dependent upon the future values of the input. So these things I have already told you. These things I have already told you in the signal system. But until that time, we have to remember. So therefore, we can say if the degree of the numerator is less than equal to degree of the denominator, then we can say the given system is said to be a causal system. Otherwise, means if the degree of the numerator is greater than degree of the denominator, then in that case, we can say the given system is said to be a non-causal system. Non-causal system. Why it is like this? Let me tell you why it is like this. So let me tell you why it is like this. Suppose if we are h of z is nothing but y of z by x of z, right? Suppose here, suppose you have degree 1, suppose here we have degree 2, here degree 3, straight into z minus 1 into z minus 2. If you are like this, then finally, let me assume you are going to get like this, right? E to the power of minus 2, to the power of minus 1, plus to the power of minus 2. Like this you are going to get. So if you multiply what you are going to get, e to the power of minus 1 into x of z, e to the power of minus 2 into x of z. So if you apply the image transform, we are going to get y of n is equal to x of n minus 1 plus x of n minus 2. So you can see the output is depending on the values of the input, the transference of the input, but not on the values of the input. So the given system is said to be causal system. It's a causal system. Suppose if the degree of the numerator is greater than the degree of the denominator, then what is going to happen? Suppose this is z cube and this is z. Like this, in small example, z cube and z. Then we are going to get z square, right? So y of z is equal to z square into x of z. So if you apply the image transform, we are going to get y of n is equal to x of n plus 2. So you can see now in this case, the output is dependent on the future values of the input. So the system is said to be a non-causal system. So therefore, I already proved here also. So therefore, we can say whenever the degree of the numerator is not equal to degree of the denominator, then only we can say the given system is said to be causal system. But if the degree of the numerator is greater than degree of the denominator, in that case the given system is said to be non-causal system. Where h of z is a transform of the impulse response h of n. So h of is nothing but y of z by x of z. So this point I have already told you. So now the next thing is, suppose what I am trying to tell you, suppose there is a system. For this system, the impulse response is h1 of n convolution of h2 of n. If the input is x of n and the output is y of n, then how can I write like this? How can I write? Very simple. I have already told you. Suppose let me take like this. So let me take here some system. So this is some system, and this is also some LTI system, other LTI systems. Suppose here suppose let me assume the input is x of n. Then what is this one? The system is also impulse response h1 of n, and the system is also impulse response h2 of n. See, I have already told you an important point. What is the point? Whenever the two systems are put in cascade, the overall system will have the impulse response. It's the convolution of the two impulse response. It will not be convolution of h2 of n. Suppose the input is x of n and the output is y of n. Here also the input is x of n and the output is y of n. Right? And the impulse response in this case is not, which is nothing but h of n. We are going to assume is h1 of n, convolution of h2 of n. So x of n, z transform is x of z. Y of n, z transform is y of z. So h of n is equal to h1 of n, convolution of h2 of n. So for this, what is the z transform? H of z is equal to I already told the condition can be on the next point in the Z function in the Z domain. It will become h1 of z into h2 of z. So we can write simply in the discrete time domain. I can write like this, which is h of z is equal to h1 of z into h2 of z, and the input is x of z and the output is y of z. So these things always you have to keep in mind. So therefore you can see this is what we have given. So if we try to convert this in discrete in the z transform, then we are going to get x of z, y of z, h1 of z into h2 of z. Same thing I intended. So this is a time domain expression, discrete time domain representation, and this is a z transform notation. So x of n will become x of z, y of n will become y of z, and this will become a product which is h1 of z into h2 of z. Similarly, what is going to happen? So I've already told you, if two things are in parallel, I've already told you when two integers are in parallel, then the overall integral system will have the impulse response, is a summation of the individual impulse response, which is h1 of n plus h2 of n. So the input is x of n and the output is y of n. So from this, if I'm going to apply the z transform, then what you are going to get? This will become x of z, this will become y of z, and this will become h1 of z plus h2 of z. So h1 of z plus h2 of z, same as it is. So this is something always you have to keep in your mind. Sometimes doing the analysis in the time domain is somewhat harder. That is the reason we try to do the analysis in a discrete, the z transform domain, and finally with the help of input z transform, we can get the value of the x of n. So this point always you have to keep in your mind. So therefore, whenever the two systems are contained in cascade, the resultant impulse response is the combination of the individual impulse response. Whenever the two systems are contained in parallel, the resultant impulse response is the summation of the individual impulse response. These things always you have to keep in your mind. So now, the next important point is, in the case of bilateral transform, initial conditions are not considered. See, in the case of bilateral transform is, you are doing integration from t is equal to minus into plus infinity, or sigma is equal to minus into plus infinity. In that case, there is no need of initial conditions. In the unilateral transform, initial conditions are considered. I already told unilateral transform is integration from t is equal to plus infinity, 0 to plus infinity, or sigma n is equal to 0 to plus infinity. In that case, the initial conditions are considered. So in that case, the initial conditions are considered. So therefore, in the case of unilateral transform, initial conditions are considered. That is the reason I have already told you one important point. Listen carefully. In the case of the Laplace transform, I will tell you. In the case of Laplace transform, I will tell you. Suppose d by dt of f of t. If you are going to apply the bilateral transform, then we are going to get s into f of s. Suppose for the same thing, if we are going to apply the unilateral transform, then we are going to get s into f of s minus f of 0. You are going to get f of 0 minus you are going to get here. So 0 minus 2 just before the instant 0. So here you can see initial conditions are considered. Then you can see initial conditions are considered. Whereas here there is no need of initial conditions. So this is a unilateral transform. So therefore we can say, in the case of bilateral transform, there is no need of any initial conditions. But in the case of unilateral transform, initial conditions are considered. So let's remember, which is that bilateral transform is we are doing the integration from t is equal to minus infinity to plus infinity, or sigma from n is equal to minus into plus infinity. So in the case of bilateral transform, initial conditions are no need. But in the case of unilateral transform, initial conditions are considered because that we are doing the integration from t is equal to 0 to plus infinity, or a sigma n is equal to 0 to plus infinity. So these things always you have to keep in mind. So in the case of bilateral transform, there is no need of initial conditions. In the case of unilateral transform, the initial conditions are considered. So this is what it is telling in this concept. In the case of bilateral transform, there is no need of any initial conditions. But in the case of unilateral transform, the initial conditions are considered. So now the next thing is, in the bilateral transform, the ROC is required with expression. In the case of unilateral transform, ROC is not compulsory to write with expression. So listen carefully. In the case of bilateral transform, for everything I have given the ROC. I have given the ROC also. I think you have remembered. For the bilateral transform, I have given the ROC. But here, no need of ROC. No need of ROC for the unilateral. So this is you have to keep in your mind. So you can see, in the case of bilateral transform, there is no initial conditions and ROC is compulsory. In the case of unilateral transform, the initial conditions are considered and there is no need of the ROC. So this is the thing that I have already told so many number of times. So finally, I can say in the case of bilateral transform, ROC is required with the expression, whereas in the case of unilateral transform, the ROC is not compulsory to write with expression. So let me give you the summary. So this is a bilateral transform. This is a unilateral transform. In the case of bilateral transform, initial conditions here, I means initial conditions. Here initial conditions are not considered. Here the initial conditions are considered. And here ROC. Here the ROC is compulsory and the ROC is no need. This is the thing for you to keep in mind. So you can see in the case of bilateral transform, the initial conditions are not considered and the ROC is compulsory. Whereas in the case of unilateral transform, the initial conditions are considered and the ROC is not compulsory. So this is the thing that we have to keep in mind. So if you remember this one, everything is very simple. See, bilateral means integration from P is equal to minus infinity to P is equal to plus infinity or sigma N is equal to minus infinity to plus infinity. Unilateral means integration from P is equal to plus infinity or sigma N is equal to 0 to plus infinity. So this is a thing I already told you. So finally, I can say in the case of bilateral transform, integration from P is equal to minus infinity plus infinity or sigma N is equal to minus infinity plus infinity. In that, there is no need of initial conditions, but the ROC is compulsory. In the case of unilateral transform, this integration from P is equal to 0 to plus infinity or sigma N is equal to 0 to plus infinity, always the initial conditions are considered, and also there is no need of any ROC. So these things I already told you so many number of times. So now the next important point is for discrete time signal, discrete time Fourier transform exists when the f of m is absolutely summable. See, for discrete time signals, discrete time Fourier transform is going to exist when f of n is absolutely summable. It is absolutely summable. So this one also I have already told you, right? So let me do the conclusion so that you can easily able to understand. So this is a continuous time Fourier transform. This is a discrete time Fourier transform, and this is the Laplace transform, and this is the jet transform. See, continuous time Fourier transform is going to exist. It is going to exist when f of t into f of t is absolutely integrable. Means integration of t is equal to minus infinity to plus infinity mod of f of t dt. If it is going to absolutely integrable, then only we can say it is said to be the continuous Fourier transform is going to exist. Similarly, the Laplace transform means integration from t is equal to minus infinity plus infinity f of t into e to the power of minus sigma t. If it is absolutely integrable, then only we can say the Laplace transform is going to exist. Discrete time Fourier transform is going to exist when sigma n is equal to minus infinity to plus infinity mod of f of n. If it is absolutely summable, then only the discrete time Fourier transform is going to exist. Similarly, the jet transform is going to exist when n is equal to minus infinity plus infinity mod of f of n or to the power of minus n. If it is absolutely summable. So this point I already told you so many number of times. So you can see the continuous time Fourier transform is going to exist when f of t is absolutely integrable. The Laplace transform is going to exist when f of t to the power of minus sigma t is absolutely integrable. When the discrete time Fourier transform is going to exist when f of n is absolutely summable, and jet transform is going to exist when f of n to the power of minus n is absolutely summable. So these things always you have to keep in your mind. So finally, I can say that the continuous time Fourier transform is going to exist when f of t is absolutely integrable, and the Laplace transform is going to exist when f of t to the power of minus sigma t is absolutely integrable, and the discrete time Fourier transform is going to exist when f of n is absolutely summable, and the jet transform is going to exist when f of n into the power of minus n is absolutely summable. These things always you have to keep in your mind. So in this case, they are saying that discrete time Fourier transform. So the discrete time Fourier transform for discrete time signal is exist when f of n is absolutely summable, means sigma n is equal to minus infinity plus infinity mod of f of n less than infinity. Now the next important formula is cos omega naught into t u of t is equal to half of e to the power of j omega naught t into u of t plus half of e to the power of minus j omega naught t into u of t. Very simple, right? cos omega naught t is nothing but e to the power of j omega naught t plus e to the power of minus j omega naught t by 2 and multiply by u of t. So therefore we are going to get like this. Similarly, sin omega naught t, u of t is nothing but sin omega naught t, we know e to the power of j omega naught t minus e to the power of minus j omega naught t by 2j and multiply by ut. Then we are going to get like this. And the amount of e to the power of j omega naught or the amount of e to the power of minus j omega naught is always equal to 1 because the amount of e to the power of j theta or the amount of e to the power of minus j theta is always equal to 1 because e to the power of j theta is equal to cos 2 plus j sin theta. Its amount is equal to 1 and e to the power of minus j theta is equal to cos 2 minus j sin theta and its amount is also equal to 1. So this is a very, very important thing. See, now the next point is, if h of t is equal to 0 for t less than 0, the given system is said to be a causal system. If h of t is equal to 0 for t greater than 0, then it is called as the anti-causal system. If h of t is not equal to 0 for t less than 0, then it is called as the non-causal system. Listen carefully. Suppose if h of t is equal to 0 for t less than 0, then it is called as a causal system. If h of t is not equal to 0 for t less than 0, then it is called as a non-causal system. If h of t is equal to 0 for t greater than 0, then it is called as the anti-causal system. So listen carefully, what is the meaning of this one? Suppose h of t is like this. Suppose h of t is like this, then it is called the causal system. Suppose if h of t is like this, then it is called as the anti-causal system. If h of t is like this, then we can say it is called as the. So this is a causal system, it is the non-causal system, and this is the anti-causal system. So this is the thing you have to keep in your mind. So whenever the h of t is equal to 0 for t less than 0, it is called the causal system. Suppose if h of t is not equal to 0 for t less than 0, then it is called as the non-causal system. So why this is a reverse of this one? This is a reverse of this one, right? Here h of t is equal to 0 for t less than 0. Here h of t is equal to 0 for t greater than 0. This is a reverse of this one. That is the reason this called as the anti-causal system. So reverse property. So what's the meaning of causal system? That the output is independent of the future values of the input. Non-causal output is dependent on the future values of the input. So finally I can say if h of t is equal to 0 for t less than 0, then it is called the causal system. And if h of t is not equal to 0 for t less than 0, then it is called the non-causal system. Similarly, if h of t is equal to 0 for t greater than 0, then it is called as the anti-causal system. So these two have the opposite properties, right? Causal means anti-causal. So this one we know. See this thing and this thing we know. I know how to explain. This have the property opposite of this one. So that is the called as the anti-causal system. Log of n by n. Log of n by n is nothing but log n minus log n. And log of m into n is nothing but log n plus log n. Because these formulas are very much useful in the civil and system course. So that is the reason I have written like this. So log of m into n is equal to log n plus log n. And log of m by n is equal to log of n minus log of n. So these formulas are always you have to keep in your mind. So log of m by n is equal to log n plus log n. And log of m by n is equal to log n minus log n. So these formulas are always you have to keep in your mind. So log of m by n is equal to log n plus log n. And log of m by n is equal to log n minus log n. So now let's go for the other important point, which is suppose let me take an integrator. So this is basically a system which is doing the integration property. Input is x of t and the output is y of t. This system, multi-system is basically just going to do the integration property. This y of t is equal to integration of e as a 2 is equal to minus m2 t x of 2 d2. We should write here 2 or t. So let me write here. This integration from 2 is equal to minus m2 t x of 2 d2. So this is nothing but what do we do? This is nothing but f of t convolution of u of t. X of t convolution of u of t, because I already told you whenever you are doing integration means whenever you are doing integration of a signal means it is a convolution of the signal with respect to u of t. So x of t convolution of u of t. Then apply the Laplace transform on the both sides. And what I am going to get y of s is equal to x of s into u of s. You know the Laplace transform of u of t. The Laplace transform of u of t is equal to 1 by s. And you already told me the Laplace transform of u of t is equal to 1 by s. So y of s is equal to x of s into 1 by s. So what is h of s? H of s is equal to y of s by x of s, which is equal to 1 by s. So h of s is equal to 1 by s. And what is h of t? Apply the Laplace inverse, then we are going to get h of t is equal to u of t. So if you want to write in the Laplace domain, what is the Laplace domain? The Laplace domain is nothing but simply here x of t will become x of s, y of t will become y of s, is indicated as the impulse response. H of t is nothing but as the impulse response H of t is equal to u of t. So here H of t is nothing but 1 by s, because u of t Laplace transform is 1 by s. Therefore we can say for integrated what is the impulse response, which is step signal itself, which is u of t. H of t is equal to u of t. So therefore you can see the impulse x of t and output is y of t. So integrated as the impulse response, which is h of t is equal to u of t. So y of t is equal to x of the combination of u of t is nothing but the integration of the input is basically doing the integration of the input. So apply the Laplace transform on both sides, then we are going to get y of s is equal to x of s into y of s. Y of s by x of s is equal to h of s. H of s is equal to 1 by s. Apply the Laplace inverse, then we are going to get h of t is equal to u of t. So for the integrator, the impulse response is nothing but which is the step signal. Why? Suppose in case if you forgot, how to get the simply what is integrated after the delta of t. Then this integrator is going to be the integration of the input. So integration of the delta of t is nothing but step signal. So h of t is equal to u of t. Very easy to remember that. So you know for integrator, if you are going to give the impulse input at delta of t, so output is nothing but h of t, which is the integration of the input. Integration of delta of t is nothing but u of t. So integration of delta of t is nothing but u of t. So therefore you can say h of t is equal to u of t. Even in the way also we can get. So different ways of getting this concept. So now the next thing is differentiator. Suppose differentiator, how to get the differentiator? Suppose if the input is x of t and the output is y of t, this is basically doing the differentiation of the input. So y of t is equal to d by dt of x of t. So apply the Laplace transform on both sides, then we are going to get y of s is equal to s into x of s. Y of s is equal to s into x of s. So then what is y of s by x of s, which is h of s? H of s is equal to s. Then h of s is equal to s, right? H of s is equal to s. Suppose if you want to write in the Laplace domain, x of t will become x of s, y of t will become y of s. For the differences of the impulse response is h of t will become h of s. So h of s is something that s we have got. H of s is equal to s we have got. Suppose if you want to know what is h of t, then how to get the h of t? H of t, how we are going to get? Very simple, right? Suppose the input is delta of t, then what is output h of t? So h of t is equal to d by dt of the delta of t. So now if you apply the Laplace transform, then what we are going to get? H of s is equal to s into delta of s. Delta of s is nothing but the impulse response of delta of s is nothing but which is 1. So h of s you are going to get 1. Therefore you can say h of t is nothing but the derivative of the impulse signal. So h of t is equal to derivative of the impulse signal. So therefore we can say for differentiator, the impulse response is the unit step signal, and for differentiator, the impulse response is the differentiation of the impulse signal. So therefore for integrator, the impulse response is the unit step signal, and for differentiator, the impulse response is the differentiation of the impulse signal. So here we know basically h of t is equal to integration of the delta of t, which is u of t, and h of t is equal to d by dt of delta of t. Very simple, right? In the case of integrator, if the input is delta of t and the output is h of t, it is the integration of the input. H of t is equal to integration of delta of t, which is u of t. In the case of differentiator, if the input is delta of t, the output is h of t, h of t is equal to d by dt of delta of t, it is nothing but same as it is. H of t is equal to d by dt of delta of t. So finally, I can say for the integrator, the impulse response is the unit step signal, and for the differentiator, the impulse response is the derivative of the impulse signal. So these things always you have to keep in mind. Now we are going to discuss another point, which is the information contained in the signal is basically preserved in the sample version. If the sampling frequency is always equal to 2 into signal frequency. I already told you, whenever the sampling frequency is greater than or equal to 2 times of signal frequency, then we can say that whatever we can get the original signal from the reconstructed signal. So therefore this is a point, as I already told you so many number of times. So let me write this point here. See, the point here is very simple. I already told you, whenever the sampling frequency is greater than or equal to 2 times the necessary signal frequency, then there will be no aliasing. No aliasing means no overlapping. So because of that, we can get back the original signal from the reconstructed signal or the sampled version of the signal. Suppose if the sampling frequency is lesser than the 2 times of lesser signal frequency, then there will be, yes, aliasing is going to get present, means there will be overlapping. So because of this, you cannot get back the original signal from the sample version of the signal. So this point always I have already told you so many number of times. So therefore we can say the information which is going to contain in a signal is basically preserved in the sample version if the sampling frequency is greater than or equal to 2 times of signal frequency. So whenever the sampling frequency is greater than or equal to 2 times of signal frequency, then the original signal or the information of the original signal is going to present in the sample version. So listen carefully that whenever the sampling frequency is greater than or equal to 2 times of signal frequency, then the original signal or the information of the original signal is going to present in the sampling version. So now the next point is, so that what is the energy in the discrete time domain? So discrete time domain, I want to write the expression. Then the formula is E is equal to sigma n is equal to minus m to plus n t mod of h of n whole square is equal to 1 by 2 pi integration over the 2 pi mod of h of e to the power of j omega whole square d omega. So what is this? This let me write here. See, I have already told you what is the energy formula in the continuous time domain. I have already told you E is equal to integration of T is equal to minus infinity 2 plus infinity mod of f of t whole square dt. And if you want to write in the frequency domain, it will become 1 by 2 pi integration from omega is equal to minus infinity to omega is equal to plus infinity, which is mod of f of omega whole square d omega. So this formula, as I already told you, so this is the formula. It is only for the, this formula is only for the continuous time case. But if you want to write in the discrete time domain, then replace f of t by f of n. So what you are going to get? Then, sorry, the integration will become summation. So let me write this part. So this is the discrete time domain expression that I am going to write, which is, can say sigma. So sigma n is equal to minus infinity to plus infinity, which is mod of f of n whole square. So this is the discrete time domain. Suppose if you want to write in the frequency time domain, then it will become 1 by 2 pi, 1 by 2 pi, integration over the 2 pi, integration over the 2 pi, integration over the 2 pi, minus pi to pi is 2 pi. We can go from minus pi to pi or pi to 2 pi, sorry, pi to 3 pi, because overall difference should be 2 pi. So which is now modulus of f of e to the power of j omega, e to the power of j omega whole square d omega. So this is the thing that you have to keep in your mind. So this is the continuous time Fourier transform and this is the discrete time Fourier transform. See, basically I have already told you, in the case of continuous time, we can say, suppose f of omega is nothing but here f of s, and in so if you substitute s is equal to j omega, then we are going to get the continuous time Fourier transform. Suppose in the f of z, if you substitute z is equal to e to the power of j omega, then we are going to get, so they will write like e to the power of omega, the f of omega, or sometimes they will write f of e to the power of j omega also they are going to write. Here they will write f of omega or f of j omega. So this one I have already told you that we can write anything. So here I want the discrete time Fourier transform. So replace it by e to the power of j omega. So they will write e to the omega or e to the power of j omega they are going to write. So here they are taking f of e to the power of j omega. This is the discrete time Fourier series. So I have already told you, this continuous time Fourier transform is not a periodic signal, it is aperiodic, but this is a periodic version. This point I have already told you so many number of times. So therefore, this is always a periodic, with a period of 2 pi. That is the reason only we have to do over the only 2 pi only we have to do. We have to do the integration over the 2 pi only we have to do. So this formula always you have to keep in your mind. So this is a continuous time case and this is a discrete time case. So continuous time case formula E is equal to integration of t is equal to minus m to plus n d mod of f of t whole square dt, which is equal to 1 by 2 pi integration of omega is equal to minus m to plus n d mod of f of omega whole square d omega. Here E is equal to sigma n is equal to minus m to plus n d mod of f of n whole square is equal to 1 by 2 pi integration over the one time period, which is omega is equal to 2 pi. We are doing with respect to omega. So omega is equal to 2 pi we have to do for the one time period of 2 pi. Mod of f of e to the power of j omega whole square d omega. where f of omega is the continuous time Fourier transform, f of e to the power of j omega is the discrete time Fourier transform. And here, it's a continuous time Fourier transform is a periodic signal, so therefore you have built integration from omega is equal to -m to plus infinity. Whereas f of e to the power of j omega, discrete time Fourier transform is a periodic signal, so you have to do only for period of 2 pi only out to the integration. So these formulas already I have told you. So these two cases always you have to keep in your mind. So this is the continuous time case and this is the discrete time case. So now the next formula is, the next one is, suppose x of e to the power of j omega, suppose x of e to the power of j omega is equal to half of 1 plus cos omega. So what is the meaning of this one? This is the discrete time Fourier transform. This is the discrete time Fourier transform of some discrete time signal. So this is what they are given. Suppose if I do the expansion, what I am going to get, listen carefully. So cos omega, you know, what is cos omega? You can write e to the power of j omega plus e to the power of minus j omega by 2. Because you know, cos 2 is equal to e to the power of j beta plus e to the power of minus j beta by 2. So from this we are going to get like this. So if we further simplify, we are going to get 1 by 4 e to the power of j omega plus 1 by 2 plus 1 by 4 e to the power of minus j omega. So this is the expression that we are going to get. Suppose if I apply the inverse discrete time Fourier transform, then what I am going to get? As what I told you, one important formula. So let me write here. Suppose I have already told you one important formula. So for x of n, what is that? Discrete time Fourier transform. Discrete time Fourier transform, I have already told you, sigma n is equal to minus infinity to plus infinity x of n into in place. So you know, in the jet transform you have to keep here e to the power of minus n, you have to keep in the jet transform. But in the discrete time Fourier transform, replace it by e to the power of j omega. So therefore I am going to grab the value of the jet. So I am going to grab the value of jet and I will write now here e to the power of j omega whole to the power of minus n. So let me grab this minus n also. So this is what we are going to get, right? So if you simplify, again what we are going to get, simply sigma n is equal to minus infinity to plus infinity x of n into e to the power of minus j n omega. So this is the discrete time Fourier transform of the x of n. So now if you substitute n is equal to 0, then what we are going to get? If you substitute, suppose if I substitute n is equal to j, n is equal to, suppose if I substitute n is equal to 0, then what I am going to get? X of 0 you are going to get. Suppose if I substitute x of 1, this n is equal to 1, then I am going to get x of 1 into e to the power of minus j omega I am going to get. Suppose if I substitute n is equal to minus 1, then I am going to get like x of minus 1 into e to the power of j omega I am going to get. So this will go on. Right? So this is the term for n is equal to minus 1. This is the term for n is equal to 1. Sorry, this is the term for n is equal to 1. Sorry, this is the term for n is equal to minus 1. This is the term for n is equal to 0. And this is the term for n is equal to 1. So like this it is going to go. So if you compare these two terms, so if you compare this equation and this expression, we can say what is the value of x of 0. So you are going to get. So what is that expression? The expression is, I am writing here, 1 by 4 e to the power of j omega plus 1 by 2 plus 1 by 4 into e to the power of minus j omega. So let me, so from this what we can say, this is x of 0 and this is x of 1 and this is x of minus 1. So we can say what is x of 0? 1 of x of 1 is 1 by 4 and x of minus 1 is plus 1 by 4. So this is the x of n. So this is the x of n. So and this arrow you have to keep because this is the value again is equal to 0. So this is what that we are going to get. So you can say what is the answer? 1 by 4, 1 by 2, 1 by 4. Same thing here. But you have to keep the arrow. The arrow indicates and this is a value at n is equal to 0. So this is a value at n is equal to 0 and this value is at n is equal to plus 1 and this value at n is equal to minus 1. So this is a very simple thing. So just if you remember the concept by comparing with what the value of the x of n. Similarly, suppose if we have some another expression, x of e to the power of j omega, suppose if they are given 4 minus 2 into e to the power of minus j to omega, if they are given, then what is the inverse discrete time Fourier transform? This is basically, I have already told, this is nothing but discrete time Fourier transform. This is nothing but discrete time Fourier transform. Right? Same thing, same as the previous case. same as the previous case. So what is that? They have given. So h of z they have given. H of e to the power of j omega they have given, which is nothing but 4 minus 2 into e to the power of minus j 2 omega that they have given. So by comparing these two equations, what I can say, the h of e to the power of e to the power of j omega means the inverse descriptive Fourier function will be h of inverse. So therefore h of 0 is nothing but simply we can say 4. Then here if you see minus j 2 omega means n is equal to 2, right? So n is equal to 2 means now h of 2. So h of 2 is nothing but minus 2. So h of 2 is nothing but minus 2. So and the remaining values are 0. So how we can write now h of n? How we can write h of n? I can write like this, which is 4 0 2, because this is at n is equal to 0 and 0 at n is equal to 1 and 2 at and the minus 2 at n is equal to 2. So this is the thing that we have to keep in mind. So what I am going to get, so this is the term that I am going to get, right? Suppose I can write in the other fashion also. How can I write? I can write like this other expression also. I can write like this, that 4 into delta of n I can write. Similarly minus 2 into delta of n minus 2 also I can write like anything. So I can write like anything. I can write either in this fashion or I can write this fashion also. Here it is same. So same thing they have given. So they have written like this. Or you can also write how you can write? You can write 4 comma 0 comma minus 2 also we can write. We can add this one. And this one also, how you can write? You can write like this, 1 by 4 into delta of n you can write, plus 1 by 2 into delta of n minus 1 you can write, plus 1 by 4 into delta of n minus 2 also you can write. You can write it this is a 0, right? So it's a carefully. So a small correction here. Let me correct this part. So a small correction. So mistake here. Small correction, only small correction, not a big one. So that we can easily able to understand the concepts what I am trying to tell you in a very detailed fashion. So this will become delta of n plus 1. It will become n plus 1. So wait a second. So it is not responding. Just wait a second. Okay. Okay. Right. So now this will become n plus 1. Then it will become delta of n. The delta of n minus 1. So we can write in any fashion. So I want you to remember only one thing. So this is an inverse discrete Fourier transform. This is not IFT. This is an IDFT. Inverse discrete Fourier transform. Inverse discrete Fourier transform. So these things always you have to keep in mind. So now the next thing is x of omega is equal to s conjugate of minus omega. Conjugate symmetry is x of omega when x of t is a real value signal. As I've already told you so many number of times. Suppose if x of t or if f of t is a real value signal, then I already told you, which is f of minus omega is equal to f of omega whole conjugate. I already told you why it is like this, because f of omega it has the real part as well as the imaginary part we are going to get. The real part is even nature and the imaginary part is ordinary nature. So let me write A is equal to f e of omega and B is equal to f o of omega I can write. So if you replace omega by minus omega, then what I am going to get f e of minus omega plus j into f of minus omega. And added on that, f of minus omega is equal to, this will become f e of omega, here it will become minus j f naught of omega. So this is nothing but f of omega whole conjugate. So therefore f of minus omega is equal to f of omega whole conjugate. The vice versa is also true. So do the conjugate of both sides. F of minus omega whole conjugate is equal to f of omega. So this concept is going to hold only for the real value signals. But for complex value signals, we can say f of minus omega is not equal to f omega whole conjugate, or f of minus omega whole conjugate is not equal to f of omega. So whatever this concept is applicable for only for the real value signal, and this concept is for the complex value signal. So these two things always you have to keep in mind. Right? So if x of omega is equal to x conjugate of minus omega, conjugate symmetry is x of omega when x of t is a real valued signal. So this concept is going to hold only for the real valued signals only. So this concept is going to hold only for the real valued signals but not for the complex valued signals. This is called the conjugate symmetry. The next point is e to the power of at into u of t as the Laplace transform 1 by s minus a. I have already told you e to the power of at into u of t as the Laplace transform 1 by s minus a, and e to the power of minus at into u of t as the Laplace transform 1 by s plus a. So in this case, e to the power of at into u of t is Laplace transform 1 by s minus a, and the ROC is sigma greater than a. The ROC is sigma greater than a. The ROC is sigma greater than a. Suppose e to the power of minus at into u of t as a Laplace transform, which is minus 1 by s plus a. It has the listen carefully, e to the power of minus at into u of t. So e to the power of minus at into u of t as a Laplace transform, which is, we can say, e to the power of at into u of t is Laplace transform 1 by s minus a, and e to the power of minus at into u of t as a Laplace transform, which is 1 by s plus a. I think this is 1 by s plus a. There is no minus. So there is no minus actually. There is no minus. There is only plus here. So 1 by s plus a. With ROC sigma lesser than, with an ROC sigma lesser than a, I guess, not minus a. So this is plus a. So this is plus a. So now what is going to happen? So now what I will do? So what I will do is very simple. Here for this one, I will replace t by minus t. So here, I will replace t by minus t. Here for this one, I will replace t by minus t. And what I am going to get? The e to the power of at I am going to get. U of minus t I am going to get. So, then what I am going to get? So, when I replace t by minus t, then what I am going to get? Very simple, right? So, just wait a second, I will tell you this concept. Let me discuss this concept here again. So e to the power of at into u of t as a Laplace transform 1 by s minus a, with an ROC sigma greater than a. Plus e to the power of minus at into u of t as a Laplace transform 1 by s plus a plus 1 by s plus a, with an ROC sigma less than plus a. Minus into e to the power of plus at into u of t, u of minus t as a Laplace transform 1 by s minus a, with an ROC sigma less than minus a. So I will discuss all these three in a very detailed manner. So listen carefully. Suppose you know already for u of t what is the Laplace transform 1 by s. The real part of s which is greater than 0, sigma greater than 0. Then you know the basic formula, which is, see if f of t has the Laplace transform f of s with an ROC real part of s, then e to the power of minus at into f of t is the Laplace transform 1 by s plus a with an ROC real part of s plus a. Let's replace s by s plus a. So now, and e to the power of at into f of t is the Laplace transform f of s minus a with an ROC f of s, the real part of s minus a. So for u of t, you know. So now I want to find what is the e to the power of at into u of t. So I already told you whenever you are going to multiply e to the power of at into u of t, replace s by s minus a. So it will become here. This will become 1 by s minus a. So a small correction here. And this is s minus a. So you have to keep here s minus a. S minus a. So now, as I already told you, in the ROC also you have to replace s by s minus a. So the real part of s minus a greater than 0 means sigma minus a greater than 0 means sigma greater than a. Yes, sigma greater than a. Then e to the power of minus a into u of t means replace s by s plus a. So replace s by s plus a means 1 by s plus a. It also replace s by s plus a means the real part of s plus a greater than 0 means sigma plus a greater than 0 means sigma greater than minus a. So therefore we got these two expressions right. So therefore we have got e to the power of at. So therefore we can say e to the power of at into u of t as Laplace transform 1 by s minus a with an ROC sigma greater than a, and e to the power of minus at into u of t as a Laplace transform 1 by s plus a with an ROC sigma greater than minus a. So sigma greater than minus a, right? So this one also I have already told you. So now what is going to happen? Suppose I have already told you the formula. If f of t into u of t as a Laplace transform p of s, and minus into f of t into u of minus t as a Laplace transform p of s, but both have the image reverse image ROC, means reverse ROC. Reverse ROC means reverse ROC are going to, one is the mirror image of the another. So one ROC is the mirror image of the other ROC. So reverse ROC means one ROC is mirror image. It's a mirror image of other ROC. Mirror image of other ROC. So this point you have to keep in mind. So we can say one ROC is the mirror image of the other ROC. So now from this, you know this expression, right? So I multiply here minus into e to the power of 80 into u of minus t means f of t is e to the power of 80 and u of t are taken. So therefore, from this formula, from this we can say that here the Laplace transform is same. Here it is 1 by s minus a. So here it is 1 by s minus a. So here also, so this thing listen carefully. This is 1 by s minus a. Right? 1 by s minus a. So this is 1 by s minus a. Right? Because if you see clearly, e to the power of 80 into u of t is Laplace transform 1 by s minus a. Right? So minus into e to the power of 80 into u of minus t as a Laplace transform same as this one. It is 1 by s minus a. With an ROC, reverse of this one. Reverse of ROC means here is sigma greater than a. So what is the reverse here? Sigma less than minus a. The reverse ROC means greater than a means what is the mirror image which is lesser than minus a. So suppose if you want me to prove this one, how we got this one, then you can see clearly for u of minus t. So u of minus t, what is the Laplace transform? Minus 1 by s. With an ROC, sigma less than 0. Then I am multiplying minus in both sides. So I multiply minus in both sides. Then what I am going to get? Minus into u of minus t as the Laplace transform 1 by s. But the ROC will never change. The ROC will remain as it is. Just you are multiplying minus, right? So just you are multiplying minus. So basically, the Laplace transform is going to get exist. The integration of f of t into e to the power of minus sigma t is absolutely integrable. So if you are going to minus means, you know, f of t or minus into f of t, both have the same modulus which is positive, right? So therefore, the ROC will remain same as it is. Here also sigma less than 0 only. So here also sigma less than 0. So now what I will do, I will multiply by e to the power of 80 for this one. So for this function I multiply by e to the power of 80. E to the power of 80 means I already told you. E to the power of 80 means t plus s by s minus a. So v plus s by s minus a. So therefore v plus s by s minus a. So here 1 by s, right? S means v plus s by s minus a. So s minus a we go. Then in place of sigma, v plus sigma by, so this is the real part of s less than 0. So here also v plus s by s minus a. So therefore we can say then the real part of s minus a less than 0 is sigma minus a less than 0 is sigma minus a less than 0 is sigma is less than a. Sigma is less than a. So actually this is plus a. Small correction, this is plus a. Sigma less than plus a. So finally here this plus a, not minus a. So this is plus a. So this is plus a. So this point you have to keep in mind. So if you see clearly, this is one is greater than a and the other is less than a. So what is the meaning of this one? I think they are just reverse, but not the mirror image. So this is just a reverse. One is greater than a means the other is less than plus a. But I think only one important thing, which is basically I can say that this is the reverse ROC, but not the mirror image. So here I'm a little bit confused, but let me clear later. But up to now, remember that this is not the mirror image. So this is only a reverse ROC. This is only a reverse ROC. So reverse ROC. So what I am trying to mean is very simple. So if you see clearly, e to the power of 80 into u of t is Laplace transform 1 by s minus a. With the real part of s greater than a. Yes, sir, sigma greater than a. E to the power of minus 8 into u of t is Laplace transform 1 by s plus a. With an ROC, sigma greater than minus a. So here I have to sigma greater than minus a. Whereas minus into e to the power of 80 into u of minus t as the Laplace transform 1 by s minus a. With an ROC, sigma less than plus a. Sigma less than plus a. Sigma less than plus a. So this is what I am trying to tell you. So this is what I have proved also. So this is what I have proved. The only small correction is here. This is sigma less than plus a. This is plus a, not minus a. So wait a second. What is ROC here? Sigma greater than minus a. Sorry, sigma greater than minus a. So small correction here. This is sigma greater than minus a. sigma greater than minus A. This is the ROC. So this is the ROC. So this is the ROC. A small fraction here. This you have to next you have to correct this one. And remaining things are same. So now you can see sigma greater than minus A, sigma greater than minus A. And this sigma less than plus A. So this is sigma less than plus A. So now you can see this is the overall thing that we are going to get. So e to the power of variable t of is the Laplace transform 1 by s minus a with an ROC sigma greater than A. And e to the power of minus 18 t of is the Laplace transform 1 by s plus a with an ROC sigma greater than minus A. And minus into the power of 18 t of minus t is the Laplace transform 1 by s minus a with a reverse ROC. Greater than A means is will be lesser than A. Lesser than A. Greater than A means lesser than A. Opposite, we can say reverse ROC means opposite ROC, opposite. Sigma less than plus A. I have put also. So this concept you have to keep in mind. See, basically, f of t into u of t is the Laplace transform p of s, and a minus into f of t into u of minus t is the Laplace transform p of s. Both are the same Laplace transform, but the reverse ROC. Reverse ROC means if one is greater than A. If one is greater than A means the other will be lesser than A. So this concept always you have to keep in your mind here. So these things you should keep in your mind. This is the thing that you have to keep in your mind. So finally I can say e to the power of 18 to u of t as the Laplace transform 1 by s minus a with an ROC sigma greater than A. As e to the power of minus 18 to u of t, which has the Laplace transform 1 by s plus a with an ROC sigma greater than minus a. And minus into e to the power of plus 80 into u of minus t has the Laplace transform 1 by s minus a with an ROC sigma less than plus a. So these two functions will have the same amount of Laplace transform, but the ROC is reverse ROC. The greater than A is here lesser than plus A. So this is finally I have confounded. This is only the reverse ROC, but not the mirror image ROC. I told you that is a wrong concept. That is the wrong concept. Finally, I can say that is the reverse ROC is the correct concept. So this is only the reverse ROC. Reverse ROC only is the correct concept. I have finally checked also. In the formula session also I have checked the concepts. Then finally I can confirm that this is a reverse ROC. If one is greater than A means the other is a lesser than A only, but not the mirror image. So plus A. So both things it is plus A. Reverse ROC means you can see if sigma this is A, right? So here greater than A means this is for one ROC means the other ROC will be this fashion. So this one you have to keep in mind. So this is a reverse ROC only, but not the mirror image ROC. So finally, normalized Gaussian function as the Fourier transform Gaussian function. So what is the meaning of this one? Let me see here. So this is in the time domain. And this is the frequency domain. So in the time domain, if you take a normalized Gaussian function, normalized Gaussian function means I already told you what is the meaning of normalized Gaussian function. So you are going to get this value as p-value as 1. This is a normalized Gaussian function. So, if you do the Fourier transform, same thing we are going to get, same picture only we are going to get, but this value is not equal to 1. So, what is this value? This value, f of omega is equal to integration of p is equal to minus infinity plus infinity, f of t into e to the power of minus j omega t into dt. So, in place of omega, I substitute 0. So f of 0 is equal to integration of t is equal to minus infinity plus infinity f of t into dt. So basically, this is the f of t. So f of t, the area under the function f of t, it is nothing but 1. So its value is equal to 1. So this is also equal to 1 only. Suppose if this value is equal to 1 means here also value is equal to 1 because the area under the probable density function is equal to 1. So it is equal to 1. So therefore you can see clearly here also its value is equal to 1 from the concept. So this one we have to keep in mind. So this is a Gaussian function and this is also a Gaussian function. So both will have the same picture. So in the time domain, the Gaussian function is there. In the frequency domain also, same picture will be present. Same picture is going to be present. So therefore we can say the Fourier transform of the normalized Gaussian function is going to give you the Gaussian function itself. So this is the thing always you have to keep in mind. So the Fourier transform of the normalized Gaussian function is going to give you the Gaussian function itself. So this point always you have to keep in mind. So now the next concept is, which is the Nyquist frequency is nothing but it's the minimum sampling frequency, which is equal to 2 times of SI signal frequency. So what is omega m? Omega m is equal to 2 pi fn. And what is fn? Fn is called the Nyquist state or the minimum sampling frequency. Sure. So omega m is nothing but 2 pi fn. 2 pi fn. So Fs is equal to 1 by Ps and Fn is equal to 1 by Pn. And what is Fn? Fn is 1 by Pn. It's a signal time delay. So very simple, right? And I've already told you, the sampling frequency is given or equal to terms of message signal frequency, then there will be no aliasing. If the sampling frequency is lesser than 2 times of message signal frequency, then the aliasing is going to get occur. The minimum sampling frequency is nothing but Nyquist frequency. So Nyquist frequency is equal to 2 times of Fn. So omega m is equal to 2 pi Fn. And Fn is called Nyquist state or the minimum sampling frequency. So omega m is equal to 2 pi Fn. Fn is equal to 1 by Ts. Fn is equal to 1 by Tn. And Fn is equal to 1 by Tn. So these things are the formula. Suppose if you take a discrete time signal. So this is the x of n. As you can see, x of n, this is a discrete time signal. So you can say it's a finite signal with finite duration. So what is the ROC of the x of n? We need to figure out. So what is the ROC of the x of n? We need to figure out. So I've already told you one important point. If a signal is having a finite domain, if it is having a power amplifier for a finite domain, then the ROC is nothing but it's all over the S2n, but excluding the point circle or excluding the infinite circle. So now, basically what is x of n in this case? X of the general formula, which is equal to sigma, n is equal to minus infinity plus infinity, x of n to the power of minus 1. So let me assume that n is equal to minus 1 and it is equal to minus 2. We are going to have some non-zero values and remaining all of the time is equal to 0. So from this we can say x of minus 1 into z to the power of plus 2. Okay. Then x of minus 2 into z to the power of, so this is plus 1. So this is plus 2. Only these terms are going to get present and remain terms of 0. So let me assume x of minus 1 is plus 1 and x of minus 2 is also plus 1. I am going to assume. So z to the power of 1 plus z to the power of 2 we are going to get. Suppose if z is equal to 0, then you are going to get x of z is nothing but 0. Right? X of z is equal to 0. Suppose if x of z is equal to infinity, then what is x of z? X of z is equal to infinity. So therefore, see, if you take any value from z, ranging from 0, 1 up to infinity. So from 0 to all these values, we are going to get some finite value. But if you substitute infinite, then you are going to get infinite value. So what is ROC? Not z is less than infinity is the ROC. What is the meaning of ROC? ROC means if you substitute all these points in the x of z, you should get a finite value. But if you substitute infinity, you are going to get infinite value. So what is the ROC? The ROC is not z less than infinity. Not z less than infinity. Suppose if it's a right-sided signal, then what is going to happen? Means only a finite domain. Only for finite domain is going to get present is n is equal to 1, n is equal to 2, y is going to be present. And in that case, what we are going to get? X of 1 into z to the power of minus 1 plus x of 2 into z to the power of minus 2 we are going to get. Suppose x of 1 and x of 2 are 1, both are 1. So you are going to get 1 by z plus 1 by z square you are going to get. Then if you substitute z is equal to 0, we are going to get infinity. If you substitute z is equal to infinity, we are going to get 0. So in this case, what is ROC? The ROC is except not z greater than 0. So except the 0, remaining all things is ROC. Because if you substitute 0, you are going to get infinity. So not z greater than 0 is the ROC. Suppose if we have both the things, see, suppose if the signal is presenting from minus 1, 0 and 1. Suppose it is present at n is equal to minus 1, n is equal to 0, and n is equal to 1. Then in that case, what we are going to get? X of minus 1 into z to the power of 1 plus x of 0 plus here x of 1 into z to the power of minus 1 we are going to get. If I assume all are 1, then I am going to get z plus 1 plus z to the minus 1. If you substitute z is equal to 0, then what we are going to get? We are going to get x of z as infinity. infinity you are going to get. Suppose if you substitute infinity, divisible infinity, then also you are going to get infinity. Then what I can say? It is not defined at 0 as well as infinity. So therefore, we can say that it is not defined at 0 as well as the infinity. It is not defined at 0 as well as the infinity. Then how can we can do? So we can get like this. So this is the ROC, we can say. So finally, I can say only one important point. I have already told you the general format. What is that? The general format I have already told you. I think you have remembered. The general format I have already told you. Suppose if the given signal x of n is a right-sided signal, then the ROC is the towards the outward of a circle. Suppose if the given signal is a left-sided signal, then the ROC is inward of a circle. Suppose if the given signal is a two-sided signal, then the ROC is nothing but bounded angular strip. I've already told you. Two-sided signal means it is an angular strip. Similarly, suppose finite duration. If it is a finite duration signal, then the ROC is all over the jet plane, excluding either point circle or infinite circle based on the conditions. Suppose if the given signal is a finite duration signal and is present only in the LHS means, then what is the thing? ROC is not yet less than infinity. Suppose if the finite duration signal is present only in the t L1 equal to 0 only for finite domain, then ROC is not yet. Listen carefully. Here what is ROC here? Here what is ROC? I already told you that the ROC is not equal to infinity. The ROC is greater than 0. So you are going to get greater than 0. Suppose if the signal is present in a form during signal, it is present in P less than 0 and less greater than 0, then the ROC is going to lie between 0 as well as infinity. So this is a very simple concept, right? I don't need to further explain. Based from this only we can say, see, if a signal is a finite duration signal and is present in only for P less than 0 means, what is ROC? The ROC is not defined at it is not defined at z is equal to infinity means not yet less than infinity. Suppose if the given signal, finite duration signal is present only in the particular equal to 0, then what is the ROC? The ROC is not yet greater than 0. In that case, the not yet greater than 0 is a thing we are going to get. Suppose if the signal is present in finite duration signal, it is presenting in both the LHS as well as RSA, for t less than 0 and t greater than 0. Then what is ROC? It is all over the explained, excluding either the point circle or either the infinite circle. These things I already told you. Angular strip means basically it is a two-sided signals. Right-sided signal means ROC is outward of a circle. Left-sided signal means ROC is inward of a circle. And two-sided signal means it is an angular strip. And if it's a finite duration signal means it is all over the plane, excluding either the point circle or infinite circle based on the conditions. I have already told you. Purely P less than finite duration signal, if it is presenting only in the P less than or equal to 0 means this is ROC. If it is presenting only in the t or equal to 0 means this is ROC. But if it is presenting in both the LHS and RHS with a finite duration means this is ROC. But in this case, what we can say, it is presenting purely in the LHS. And what is ROC? Not yet less than infinity. So this point I have already told you. So now the next concept is, suppose if the signal h of t is equal to e to the power of minus 3 into t plus 1 into sine of 4 into t plus 1 into u of t plus 1. So what is the Fourier transform that we need to figure out? The Fourier transform is nothing but h of omega is equal to 4 by j omega plus 3 whole square plus 4 square into e to the power of j omega. So this is the Fourier transform that we are going to get. So how to get this one? Let me try this one. Suppose first what I will do a simple thing. What I will do is basically, so listen carefully, e to the power of minus 3t into sine 4t into u of t. So for this one, I will try to find the Laplace transform. First of all, I will find the Laplace transform. What is the Laplace transform? So you know the Laplace transform formula, right? There is a Laplace transform. Laplace transform is sin omega t is omega by s square plus omega square. Then e to the power of minus 18 means replace s by s plus a. Replace s by s plus a. Then a is equal to 3 and omega is equal to 4. Then what you are going to get? 4 by s plus 3 whole square plus 4 square. So it is nothing but simply I can say that 4 by s plus 3 means simply how you can write s plus 3 whole square plus 4 square is nothing but same thing and going to get same heritage. So this is for this one. Suppose the Laplace transform and Fourier transform is same. S3 plus s by j omega. Then we are going to get the Fourier transform. So we have the power of minus 3 into sine 4t into u of t. Fourier transform is in the Laplace transform. I have to substitute j omega. That's it. So 4 by j omega plus 3 whole square plus 4 square. So suppose now what I will do, I will replace t by t plus 1. So I already told you for f of t, the Laplace transform. What is the Laplace transform is nothing but here I already told you what is the Laplace transform f of t means f of s. Then for e to the power of f of t minus a as the Laplace transform e to the power of as into f of s. E to the power of minus as into e to the power of minus as into f of s, right? F of t minus as Laplace transform e to the power of minus as into f of s. So here a is equal to minus 1. Here a is equal to minus 1. So a is equal to minus 1. A is equal to minus 1. So what you are going to get? E to the power of s into f of s. So here we have to multiply e to the power of s. E to the power of s. That's it. So e to the power of s. So this is the Laplace transform that we are going to get. 4 by s plus 3 whole square plus 4 square. So if you want the Fourier transform, is replace s by j omega. So e to the power of j omega into 4 by j omega plus 3 whole square plus 4 square. Very simple, right? What I have done, first I have found the Laplace transform and then finally I have substituted for j omega. Then I got the Fourier transform. It's very simple, right? So what I have did first, basically I have found the Laplace transform. Then finally I have substituted s equal to j omega. So for f of t, the Laplace transform is f of s. And f of t minus as the Laplace transform e to the power of minus as into f of s. So f of t is the Laplace transform f of s. And f of t minus as the Laplace transform e to the power of minus as into f of s. So for this one, I have found the Laplace transform, which is 4 by s plus 3 whole square plus 4 square. So here a is equal to minus 1. Hence I am going to replace t by t plus 1. Then what is the Laplace transform e to the power of s into f of s. F of s, for this I have multiplied by e to the power of s. So this is the Laplace transform, but we need the Fourier transform there. So replace s by j omega. So we are going to get this one. So this is the Fourier transform. This is the Fourier transform. So now the next thing is integration of t is equal to minus infinity plus infinity by x of t into y of t dt. So how we can write? How you can write, which is equal to 1 by 2 pi integration of the omega is equal to minus infinity plus infinity x of omega into y of omega d omega. So what is the meaning of this one? Let me simplify. Suppose one signal is there in the product. Suppose let me tell you. So x of t into y of t dt is nothing but 1 by 2 pi integration over the omega is equal to minus into plus into x of omega into y of omega into t omega. So this is the thing that you have to keep in your mind. So integration of t is equal to minus into plus into x of t into y of t dt is nothing but 1 by 2 pi. So let me tell you the concept. So that you can easily able to understand. Suppose if x of t has the Fourier transform x of omega, then y of t has the Fourier transform y of omega. Then x of t into y of t is nothing but the product in that conjunction domain relates to conjunction of frequency domain, which is what's the Fourier. Suppose p also this is p of t. Then this is p of omega. P of omega is equal to 1 by 2 pi x of omega animation of the y of omega. So this is a thing here. Suppose if I want to do the integration of this signal, then integration of the p of t. So integration of the p of t is nothing but integration of p of t is nothing but simply I can say that integration of p of t is nothing but what you are going to get. So I can say like this: p of omega by j omega, right? So now, this is what we are going to get, right? So now, listen carefully. What I will try to tell you is very simple. So let me do some analysis so that we can easily able to understand what I am trying to tell you. So this is a P of T signal, right? So now I want to find what is the energy of the signal I want to find. So basically, what I want to find, I want to find what is the energy of the signal P of T. So energy is equal to integration of E is equal to minus T plus infinity P of T whole square dt. So this is the energy. This is the energy. So what I will do? I will do basically integration. So what I will do? Integration over the P is equal to minus T plus infinity P of T dt. So what is the meaning of this one? Basically, I want to find what is the area under the signal P of T. I want to find what is the area under the signal P of T. I want to find what is the area under the signal P of T. So I want to find what is the area under the signal P of T. Then I know P of 0. P of 0 is up in the, we are going to get like this. So what I told you, the area under the signal, so under the, if you want to find what is the area under the signal P of T, then what I have to do, in case of omega I have to substitute 0. In case of omega I have to substitute 0. Okay? So now, what I will do the basic thing, which is simply like this. So this is the thing here, P of 0 is something, P of 0 is equal to integration of P is equal to minus T plus infinity P of T into dt. P of T into dt. This is a thing that you have to keep in the mind. So this is a thing that you have to keep in the mind. Basically, this relation I am unable to prove right now. So I want you to remember this formula, which is integration of T is equal to minus 70% of the x of T into y of T dt is equal to 1 by 2 pi. Integration from omega is equal to minus 70% of the x of omega into y of omega d omega. So I want you to remember this formula. I want you to remember because I am unable to prove this one right now. So I request you to remember this formula, which is integration of T is equal to minus 70% of the x of T into y of T dt is equal to 1 by 2 pi. Integration over the omega is equal to minus 70% of the x of omega into y of omega d omega. So I want you to remember this formula. So for x of T, the Fourier transform is x of omega, and for y of T, the Fourier transform is y of omega. So integration of T is equal to minus 70% of the x of T dt, x of T into y of T dt is equal to 1 by 2 pi. Integration of omega is equal to minus 70% of the x of omega into y of omega d omega. So we can say integration of T is equal to minus 70% of the x of T y of T dt is equal to 1 by 2 pi. Integration over the omega is equal to minus 70% of the x of omega into y of omega into d omega. So finally, I can say that integration of T is equal to minus 70% of the x of T into y of T dt is equal to 1 by 2 pi. Integration over the omega is equal to minus 70% of the x of omega into y of omega into d omega. So this formula I want you to remember. So now the next is for x of T is equal to 1 by s3 plus t square. The Fourier transform is x of omega is equal to pi by j into e to the power of minus a into mod of omega. So this I am going to derive. So listen carefully. This formula I am going to derive. So you have to keep in your mind these basic things to get this one. So I have already told you, which is for e to the power of minus a into mod t as the Fourier transform. That is the Fourier transform we are going to get. That is 2a by a square plus omega square. So this is what that we are going to get for this signal. So now what I will do basically, suppose you know the basic formula, which is for f of t, if the Fourier transform is f of omega, then capital F of t as a Fourier transform 2 pi into f of minus omega. So what I will do is I will write in the time domain. So 2a by a square plus b square is wherever omega is there, I have replaced omega by t. So what is the Fourier transform? 2 pi into, here I have to replace t by minus omega. So e to the power of minus of, here we have to replace t by minus omega. So you know, mod of minus omega is equal to plus omega only. So 2 pi into e to the power of minus of Minus omega plus omega is same because anyhow you should get always positive value. So omega either you take minus value or either you take positive value. Anyhow which is same because modulus of A. So modulus of A is equal to modulus of minus A. If A is equal to plus 1, then mod of 1 is equal to mod of minus 1, which is equal to 1. So I can write everything. So therefore mod of A is equal to mod of minus A. Suppose if you substitute A is equal to minus 1, then your body is going to get mod of minus 1 is equal to mod of minus 1 is mod of A is equal to minus 1 every time. So mod of minus 1 is equal to mod of minus 2 is plus 1, which is always equal to 1. So you can write anything. So this is the thing that we are going to get. So now what I will do, so for the signal this is the Fourier transform. So what I will do, I will divide 2a over both sides. So what I am going to get here, 1 by a square plus b square as a Fourier transform 2 pi by 2a into e to the power of minus a into mod of omega. So if 2 cancels, we are going to get finally here. We are going to get finally pi by a into e to the power of minus a into mod of omega. For 1 by a square plus b square. So this is what we have got. So this is a formula. So 1 by a square plus b square Fourier transform is pi by a into e to the power of minus a into mod omega. Same thing I have written down. So x of a is equal to 1 by a square plus b square, the Fourier transform x of omega is equal to pi by a into e to the power minus a into mod of omega. So by using this relation, so remember, e to the power of minus a into mod is a Fourier transform of a by a square plus omega square. So if of t is a Fourier transform for omega, then capital F of t has a Fourier transform 2 pi into f of minus omega. So this is the duality. So here in place of omega I substitute t. Here 2 pi into, here in place of t I have replaced t by minus omega. So here going to get this one. Mod of minus omega is equal to mod of omega. Then I have divided by 2 and both sides, then I am got 1 by a square plus b square is a Fourier transform pi by a into e to the power of minus a into mod of omega. So this one I already told. Now let's go for the another point, which is if y of t is equal to sinc of t, Fourier transform which is y of omega is equal to rectangle of omega by 2 pi. So rectangle of omega by 2 pi that we are going to get. So how to get this one? Let me prove here. So let me prove. So let me prove this concept. See, I already told you. Suppose if you have a rectangle pulse, suppose if you have some rectangle pulse of amplitude k and a width of t. Width of t means this is p by 2 and this is minus t by 2. So what is the Fourier transform? I already told you. Suppose this is x of t. Then what is this x of omega? So x of omega, you know, is area. Area is nothing but a into t. Sa of omega into what is the width here? T. So this is what we are going to get here. So now what I will do? I will simplify. So I will simplify. So if I simplify what I will, sa of x is equal to sin x by x. Sinc of x is nothing but sin pi x by pi x. So if you compare, what I can say? So if you compare what I can say, sinc of x is equal to sa of pi x. Right? In place of x, if we replace x by pi x, we are going with this function. So sinc of x is equal to sin of pi x. Suppose if I want to write in terms of sinc, then what I have to write here? Sinc x. Sinc x is equal to sa of pi x. Sa of pi x. Suppose, suppose what is a pi x here? Pi x is nothing but I am going to assume omega into p by t. Then what is x here? Omega into p by 2 pi. Right? So here x into p here. This sinc of x is nothing but omega into p by 2 pi. Right? So this is the thing we have to keep here. Right? So you can either write like this one or either you can write like this one. The concept is same. So now what I will do, very interesting thing that I am going to do. So now I will apply the duality principle in place of omega and replace by p, and I am going to get here a2 into sinc of small t into capital T by 2 pi. Because of omega I have replaced here. So what is the Fourier transform? Just 2 pi into f of minus omega. Here f is about x of minus omega. So x of minus omega is the same as it is because it is a even signal. So it will become same as it is. So multiply by 2 pi. So 2 pi means we are going to get like this. So we are going to get like this. So this is something that we are going to get. This is 2 pi a. This is t by 2 and this is minus t by 2. This is with respect to omega. So this is a signal that you are going to get like this one. So now the question what they are given, simply see divide by 80 on the both sides. If I divide by 80 on the both sides, then what I am going to get, I am going to follow simplification. Suppose if I am going to divide by 80 on the both sides, suppose let me assume 80 is equal to 1. Let assume 80 is equal to 1. 80 is equal to 1. And also t by 2 pi is equal to 1. I am going to assume 80 is equal to 1 and t by 2 pi is equal to 1. But what is the meaning of this one? T is equal to 2 pi. And if t is equal to 2 pi, then what is a? A is equal to 1 by 2 pi. Right? Listen carefully. T by 2 pi I am going to assume its value is equal to 1. And 80 is equal to 1 I am going to assume. So a is equal to 1 by 2 pi I am going to get. And t is equal to 2 pi you are going to get. So therefore, what I can say? I can say like this. I can write like this now, right? So sink of t has the Fourier transform, which is, you know this is the graph, right? So for this graph, now a is equal to 2 pi. A is equal to 1 by 2 pi. So if you multiply, what you are going to get? 2 pi into 1 by 2 pi is equal to 1. So you are going to get that. This height as 1 you are going to get. So this height as 1 you are going to get. Now what is t? T is equal to 2 pi. T is equal to 2 pi. So this is t by 2. Plus 2 pi by 2 is equal to 5. Here also minus 2 pi by 2 is equal to minus 5. So this total is 2 pi. So this is what you are going to get. So this is the t that we are going to get. So for sink t, the Fourier transform is this one, which is the t is the rectangular pulse of width 1 of a t value of 1 with a width of 2 pi. So same thing. For sink t, what is the Fourier transform? Which is it is having a we can say the height of 1, height of 1 with a width of 2 pi with respect to omega. So you can see this, you can write like this: rectangle of omega by 2 pi. Rectangle of omega by 2 pi. This we can define like this. So what is the meaning of this one? Here the function is omega and here the width is 2 pi with a peak of 1. So rectangle omega 2 pi means it is defined with respect to omega. It is defined with respect to omega with a peak value of 1 with a width of 2 pi. So we can write like this. We can write it like this, but this is actual graph. So I have already proved each and everything. So you can easily able to understand that what I have proved. So these things always you have to keep in mind. So the next thing is, if x of s is equal to 1 by s plus 1, the inverse Laplace transform is. So if x of s is equal to 1 by s plus 1, the inverse Laplace transform is x of t. Suppose for x of s is equal to 1 by s plus 1, what is the inverse Laplace transform x of t? X of 2s means s by 2s, we are going to get 1 by 2s plus 1. Then e to the power of minus as into x of s. What is the inverse Laplace transform? Which is x of t by t minus a. See, I have already told you one important point. See, if x of t has the Laplace transform x of s, then x of t minus a has a Laplace transform e to the power of minus a s into x of s. Same as it is. This is the Laplace transform, inverse Laplace transform is reverse. So this is a very basic thing. It's a concept I have given. So x of t is the Laplace transform x of s. X of t minus s is the Laplace transform e to the power of minus a s into x of s. See, x of 2s means wherever s is that equals s by 2s. So like this we are going to get. I am going to give you some general idea. So these things you have to keep in your mind. Now we are going to discuss another important point. Suppose if x of t is equal to e to the power of minus a into mod of t, we can say signal function of t. So how we can write? Signal function of t means u of t minus u of minus t. As I already told you. So if you multiply, we are going to get e to the power of minus a into t, u of t minus e to the power of at into u of minus t. Because I have already told you one important point. E to the power of minus a into mod t into signum of t. Signum of t means u of t minus u of minus t. So therefore, if you multiply, what you are going to get? So you can say clearly, let me write here. So x of t is equal to e to the power of minus a into mod t, and signum of t means u of t minus u of minus t. So if you multiply, what you are going to get? E to the power of minus a into mod t into u of t minus e to the power of minus a into mod t into u of minus t. See, as u of t is defined for t greater than or equal to 0. So here also t is also greater than 0. So t is a positive. So mod of t is equal to t. So e to the power of minus at into u of t. Here, u of minus t is defined for t less than 0. So in the case t is negative. So we have to replace t by mod of t as minus t. So here we need minus positive. So e to the power of at into u of minus t. So therefore, this is what they are going to get. Means I already told you mod t is equal to plus t for t greater than or equal to 0 and is equal to minus t for t less than or equal to 0. So here t is greater than or equal to 0. So replace mod t by t. Here t is less than 0. So replace t by mod t by minus t. So this is what that we are going to get here. So now what I will do is x of t. So I want to find what is x of omega. So x of omega is nothing but e to the power of minus at into u of t. So what e to the power of minus at into u of t? What is a Fourier transform 1 by j omega plus a minus of e to the power of at into u of minus t. So what is the Laplace transform of this one? So basically, for u of t, what is the Fourier transform? The Fourier transform, sorry, for the u of t. So for the u of t, the Fourier transform. What is the Fourier transform? Which is 1 by j omega plus pi into delta of omega. So these things. And I already told you, which is I already told you this formula. So basically what I have did, e to the power of at into u of minus t means I have replaced t by minus t. Replace t by minus t. So replace omega by minus omega. So you are going to get minus j omega plus a. Minus j omega plus a. So if you simplify, what you are going to get? You are going to get minus 2 j omega by a square plus omega square. As I have already told you, suppose if f of t has a Fourier transform, f of omega, then f of minus t has a Fourier transform, f of minus omega. Because that is the formula f of at as a Fourier transform, f of at as a Fourier transform, 1 by mod a into f of omega by a. A is equal to negative. So we are going to get this relation because minus 1 mod is nothing but plus 1 only. So these things always you have to keep in mind. So this is what they are going to get the Fourier transform. So x of omega is equal to minus 2 j omega by a square plus omega square. So minus 2 j omega by a square plus omega square. These things I have already explained. So for e to the power of minus 8 into u of t, the Fourier transform is 1 by a plus j omega minus s minus as it is. So we plus t by minus t, and we are going to get the Fourier transform t plus omega by minus omega. So we are going to get this one. If we simplify, we are going to get minus 2 j omega by a square plus omega square. So now the next point is, suppose this is some system. So what is the equivalent model I can write? So you can see here this one is nothing but x of t. X of t is signal as it is. Here the signal is x of t. Here what is the signal? X of t convolution of h1 of t. So what is y of t? Y of t is equal to x of t plus x of t convolution of h1 of t. So now in x of t I can write like this. X of t as x of t convolution of the delta of t I can write because I know x of t plus x of t convolution of h1 of t. So what I can do? I can take x of t as a formula. X of t convolution of a delta of t plus h1 of t. So if we simplify, same thing we are going to get x of t convolution of delta of t plus x of t convolution of h1 of t. So this is the y output we are going to get. So what is the net impulse response? Delta of t plus h1 of t. So this is the net impulse response. Delta of t plus h1 of t is the net impulse response. So for the system, what is the overall impulse response? The next point is, suppose for e to the power of n into u of n, for e to the power of n into u of n, what is the jet transform? Z by z minus a. So what is the ROC? The ROC is nothing but mod z greater than a mod a. A can be either positive or A can be negative or A can be even complex number. And I already told you, here it is a signal is a right side signal. Means f of n is equal to 0 for n less than 0. The signal is equal to right side signal. So ROC is always out to the circle which is mod greater than mod a. Similarly, minus a 1 the power of n into u of n is re plus a by minus a. Re plus a by minus a, we are going to get z by z plus a. So in this case, re plus a by minus a, we are going to get this one. So ROC is same thing because minus a mod is nothing but plus a only. So modulus of minus a is nothing but plus a. Plus only. So therefore, you can write margin greater than mod only you can take. Whether we have already told you modulus of minus a is equal to modulus of plus a. You can write it as it is. So here also same thing. A can be positive, negative, or A can be even complex number. So this is a very simple, right? I don't have to explain more thing. So the ROC is same. So we can say for a to the power of n into u of n, the z transform is z by z minus a with an ROC mod z greater than mod a. Or A can be either positive, or A can be either negative, or A can be either complex. Minus a whole to the power of n into u of n. So re plus a by minus a, we are going to get z by z plus a with an ROC mod z greater than mod a, where A can be either positive, A can be either negative, or A can be even complex also. So now let's go for the another point. Suppose if h of z is equal to half minus 1 by 4 into z to the power of minus 1, then what is the h of n? So this is a basic formula. I don't need to further explain, but let me tell you. So for h of n, what is the x of z? X of z is equal to sigma n is equal to minus infinity plus infinity x of n into z to the power of minus n. Right? So now, if you are going to expand this one, you are going to get like this. It is x of 0, x of n is equal to 0, you are going to get plus x of 1 into z to the power of minus 1, and it goes on. Like this you are going to get. So in the question what they are doing, h of z is equal to half minus 1 by 4 z to the power of minus 1. So by comparing these two, what we can say, h of 0 is equal to half and h of 1 is equal to minus 1 by 4. So what is the impulse response? The impulse response is half comma minus 1 by 4. So this is happy, this one. This is equal to 0. This is the arrow that we have to keep. So this is what that we are going to get. So we can also write this one in the other format. In other format, how we can write? We can also write like this, h of n is half into delta of n minus 1 by 4 into delta of n minus 1. So like this also you can write 1 by 2 is nothing but 0.25. 1 by 4 is equal to 1 by 2 is equal to 0.5 and 1 by 4 is equal to 0.25. Right? Same thing. Same thing. Half delta of n minus 1 by 4, delta of n minus 1. Half means 0.5, 1 by 4 is 0.25. Same thing I told you. So now the next point is, suppose if you take a LTI system, see, LTI system is, suppose if the input is h of n and the impulse response is h of n, then what is y of n? Y of n is equal to x of n, convolution of the h of n. Suppose we now do the z transform, so x of n z transform x of z and h of n z transform is h of z. Then what is y of z? Y of z, sorry, the y transform of the z transform of y of n is y of z, which is equal to the conversion can do only z transform. So it will become x of z into h of z. So y of z is nothing but x of z into h of z. So now if you want to find the final value, y of n is equal to z tends to 1 minus z to the power of minus 1 into y of z. So what is y of z? Y of z is equal to x of z into h of z. So this formula has already given the initial value theorem and the final value theorem. So this is in the Laplace transform and this is in the z transform. Let me tell you, the initial value theorem is nothing but, we can say that limit s tends to 0 infinity s into f of s, and here f of infinity is equal to limit s tends to 0 s into f of s. Here t is equal to 0 means s is equal to infinity. Here t is equal to infinity means s is equal to 0. So these two you always have to keep in mind. Z transform. Z transform is, here also same thing, f of 0. Here limit s tends to. So already I told you what is z, that is equal to f of s. If s is equal to infinity, z is also equal to infinity. So this is how to write z tends to infinity. 1 minus z to the power of minus 1 into f of z. So if you simplify, what you are going to get? 1 by z. 1 by z is nothing but that is equal to infinity, 1 by z is equal to 0. So 1 by z is equal to 1. So you are going to get like this. Simplify. You can also write like this. This is equal to limit z tends to infinity. F of z also like that. And what is f of infinity? F of infinity is equal to limit. S is equal to 0. So if substitute S is equal to 0, Z you are going to get its value is equal to 1. So 1 minus Z to the power of minus 1 into f of Z. So if you go to simplify, how we can write this one? Z minus 1 by Z and Z is equal to 1. So you can write limit Z tends to 1, Z minus 1 into f of Z. In different ways we can write. So from this we can get the initial value as well as the final value. So this concept already I told you. So this is the Laplace transform and this is the Z transform. Same thing, what is the final value? Y of infinity is equal to, if Z tends to 1, 1 minus Z to the power of minus 1 into Y of Z. And Y of Z is nothing but X of Z into H of Z. So this concept you can see clearly here. So now, the next point is, if X of n is equal to Z to the power of n, then Y of n is equal to Z to the power of n into H of Z. And Z can be any scalar number. In this case only. See, I've already told you this point also. This point also, I've already told you. Suppose if we take some LTI system, if we say take some LTI system of any impulse response H of n. Suppose if the input is A to the power of n, then what is the output? I've already told you. A to the power of n into H of A. I've already told you. Suppose if A is equal to Z, then what you are going to get? The input is Z to the power of n and the output is Z to the power of n into H of Z. H of Z is a some complex scalar quantity. It is a complex scalar quantity. Scale version of the input on the scalar quantity. So output is the scale version of the input. So that is the reason the input is called as the eigenfunction for this LTI system. If the output is a scale version of the input, then the given input is called as the eigenfunction for the given LTI system. So always remember that if the output is a scale version of the input, then the input is called as the eigenfunction for the given system. So this point always you have to keep in your mind. So the input is Z to the power of n. What is the output? Z to the power of n into H of Z. So X of n is equal to Z to the power of n. So Y of n is equal to Z to the power of n into H of Z. Z can be any scalar number. So now the next thing is X of n is equal to cos n pi. Cos n pi is equal to minus 1 over the power of n. So you know, if you substitute n is equal to n is equal to integers, n is equal to integers. Suppose if substitute n is equal to 1, so cos pi is equal to minus 1. Suppose if substitute n is equal to 2, then you are going to get plus 1. So that is the reason cos n pi is always equal to minus 1 over the power of n, where n is equal to integers. Similarly, sine function will have zeros, but theta is equal to n is equal to integers. I already told you. Similarly, cos theta will have the zeros out of 2n plus 1 into 1 by 2, where n is equal to integers. So you can cross it. Suppose if you substitute n is equal to 0, suppose if you substitute n is equal to 1, here theta is equal to 5 plus sin is equal to 0. If you substitute n is equal to 1, you are going to get 3 pi by 2. So 3 pi by 2 plus, and if you substitute n is equal to 0, pi by 2 plus 0 cos 0. At 3 by 2 also cos function is 0. So therefore, then we finally can say cos n pi is always equal to minus 1 over the power of n, where n is the integers. And the sine function will have the 0 crossing at theta is equal to n pi, where n is the integers. And the cos function will have the zeros at theta is equal to p1 plus 1 into pi by 2, where n is the integers. So these points always you have to keep in your mind. So these are the important things always you have to keep in your mind.